Pause the music. Hello, it's happy welcome to the community meeting. It's been a while since we've done a community meeting. We tried to leave it until the point where we've got some proposals to go through the working group process. Last time we went through some 3.0 proposals, as we have the past couple of meetings, which is, as you may know, is a complete rewrite of the library. Some of the proposals we reviewed today are revised versions of the proposals that we reviewed last time. And this is just in response to some conversation and some new APIs that we'll be proposing today. Does anyone else have anything to report community meeting wise to before we start in terms of what's going on in the project?
Don't think so.
Not really, no.
Yeah, I will say it's feeling like we're for the first time in like the 5 years we've been. I feel like it's been 5 years, maybe 4 years that we've been talking about 3.0. But it feels like for the first time in that time that we're actually kind of close to having something that we can release as a preview on. So it's good progress is being made, and we've just got some proposals to discuss today that, if approved, we're discussing windowing today, and we've already got an implementation of what's proposed. I know it's kind of that's not supposed that's not supposed to be how the proposal process works, but if it's approved as is, then it merges, and then we've just got input to do, and I think OpenAL bindings is the other one on the tracker for 3.0 preview 1, so we are getting close. Anyway, I guess unless anyone else wants to jump in, we can get into the first proposal. No one else has jumped in. Let's get into it. Alright, so the first proposal is one that's been on the back burner for a while. It's been waiting for review. 8 months ago. Wow. So this one is there's been a lot of discussion recently in the Silk.net server about where we draw the line for adding bindings to Silk.net, and because we've kind of operated on like some headcanon of, well, if it's an industry standard, then it's okay. Otherwise, we don't want it in the main library. And it's become clear that our users have a lot of varying use cases, and there's a lot of auxiliary libraries that surrounds the bindings that we have as part of our core binding set, that we have to send users to third-party libraries for, or that might not meet our quality standards, or just not be as usable as Silk.net is. And to be honest, one of our main selling points is that we're sort of like one library for everything. I think that's a lot of the reason why so many people choose Silk.net, is that we've got loads of stuff. So obviously we are currently a two maintainer team, going down to one once 3.0 launches. So we can't really add everything to Silk.net because it becomes a maintenance nightmare. So what is contained in this proposal is it's formalising the governance procedures that we've sort of kept in our heads and have done ad hoc already. But it also defines the concept of an additional binding, and bindings owners, which is supposed to be this other role separate from the maintainer role. So the idea is that for things that we don't deem to be industry standard, or like massively recognized, massively popular, or that we don't need to achieve our high-level utilities that go through the working group process, that we can bring in passionate community members that just focus on one additional binding, aren't interested in becoming like a whole Silk.net maintainer, and have that responsibility. And so long as they follow a bunch of requirements that is set forth in this document, that they can come in, expand our binding set, and in return they just keep it up to our standards, and if not, then we stop shipping that binding. It's kind of like an ad hoc thing, and I feel like it strikes the balance really well in not exploding the maintainer team responsibilities, not expanding the maintainer team responsibilities, but also expanding the amount of Silk.net there is for our users. Um, so yeah, to sort of go through the proposal, there's a lot of text, and this is why I put in the Help Wanted channel. Please read it, because we're not going to go over every nuance, every sentence, every word that is in this proposal. But basically, we sort of reverse engineered the criteria that we used for 2.x in determining what ends up in the main library. It basically ended up with we need to be able to bind with it and have an open source MIT binding to the library. There needs to be there needs to be at least one open source. Although that's interesting. It basically, the API needs to be open source. And have an implementation that is open source unless it's like a standard. And then it also needs to be maintained by someone that's recognized, like an industry body like Kronos and Microsoft, or aid in the creation of apps making use of those APIs, or we need it to implement like windowing or input. And that's the best reverse engineering we could come up with. Again, that's just informational. That's not a normative part of this proposal. But going through this proposal, when I wrote it, it was me live thinking through, like going through the thought process of how we can bring in those additional bindings. So it goes through a lot of the history. It goes through what we're doing now, and it goes through sort of where our head is at. Like for when we were discussing text rendering libraries, Kai very much succinctly summarized it as, we don't want to just bind to 25 text libraries in the hopes that one of them works for everyone, because that's ridiculous. And that's been why we've kind of shied away from places where there are very well-known APIs, but it's not clear which one should be used over the other, which one we should be pushing. We there's a bunch of stuff picking apart like that existing criteria and how we want to expand upon it. But yeah, our mission is always to be the one-stop shop for your .NET multimedia applications. So yeah, in the code ownership part of the proposal, we mainly just go over like all the different people that are involved in creating Silk.net. This was primarily just to document how the Silk.net project operates for future maintainers and future people involved, and so that we're transparent about that. It goes over what the .NET Foundation does, our relationship with them. It goes over what's a high-level utility. It goes through it actually documents the proposal process, which we hadn't done before, apparently, and just silly things like that. But the main thing is that we identified that maintainers should only be responsible for the core functionality of Silk.net and core bindings, and also the core high-level utilities as well, like windowing and input. And anything beyond that, a maintainer shouldn't necessarily concern themselves with, and that should instead go to a binding owner. And yes, we've one of the notable things. This was in response to a Discord conversation. Is that with the definition of our bindings, we have sort of loosened the high level utility definition a little bit to allow C# friendly wrappers to be created that are still faithful to the original API. Like, they're not trying to change the concepts, they're not trying to introduce their own way of interacting with the native API. Basically just thin wrappers that just make it a bit more usable. We now allow those without going through the proposal process, because the idea is that we're not changing any concepts, and whoever designed the API went through all the conversations that we will be having in the working group meeting otherwise. So to define a core API, a core binding, we have decided that it is an API existing in the multimedia or compute space, or aids the creation of applications using those APIs again. It must be used as a dependency by one of our working group approved high-level utilities. It's part of our core functionality, or it's a core binding. And then the third one, the third criteria is it needs to be a multi-vendor standard. But the critical thing here is that it must only be two or more of these things. So it could be an API existing in the multimedia space. It can be developed by a multi-vendor standards team or a notable industry presence body, but it doesn't have to be used by us. Likewise, if there's something that we're using as part of our high-level utilities that isn't necessarily developed by that multi-vendor standards team or isn't widely recognized, if it isn't widely recognized, you kind of question why we're using it in our high-level utilities in the first place. But the idea is that if we're using it as a high-level utility, it naturally becomes core binding because we have to maintain that API to keep our library working. So with that criteria, oh yeah, and it must have a license that allows us to create a binding in the first place. And as a result of these criteria, we determined that GLFW and SDL both meet these requirements today, given the state of 2.x, but GLFW won't have that status in that core binding status in 3.0 because we're not using it as part of our windowing high-level utilities, and it doesn't meet that multi-vendor standards team notable industry body requirement either. So although it is notable, because it doesn't meet one of the two other requirements, it means it gets demoted to an additional binding, which as it currently stands, we don't have GLFW bindings at all in 3.0, and I don't think that's going to change. But the beauty of this proposal is that we have the concept of additional bindings, which are bindings that don't meet those requirements, but they're libraries that are helpful for users making use of Silk.net, of the core binding set that we have. So in theory, if someone wanted GLFW bindings and was willing to put their money where their mouth is and become a binding owner, they would basically be responsible for that specific part of Silk.net in the Silk.net repository. And they'll be responsible for keeping it up to date, making sure it's following our standards. So that requires a lot of participation with the main team, but basically it's the binding owner responsibility to make sure that the binding is spick and span. They also entitled the bindings owners for a particular binding are allowed to go through their own mini working group meetings as well, completely independent of the main working group or the maintainers team, if they wanted to design their own high-level utilities that do deviate from the native API, but are still within the context of that specific binding. And that's probably because some additional bindings do justify developing those sort of wrappers, and we didn't want to constrict our additional bindings. So basically, this we allow them to define high-level utilities, but as long as they go through a process similar to the one that we're going through today for the high-level working group, i.e., they have their documented meetings, they have these sorts of discussions. A maintainer doesn't necessarily have to attend those discussions. But a maintainer does have to sign off that the proper process has been followed before a high-level utility is allowed in. But the idea is that all those high-level utilities are scoped to that specific binding. If there's a high-level utility that they want to develop that expands beyond the scope of their binding, like someone wants to make a GPU wrapper that's API agnostic, at that point, then they have to take it to the top level working group and have it evaluated as if it was affecting all of Silk.net as we are today, which is fine because in practice that means it's just going through the same process. It's just some different people involved because the individual maintainers are unlikely to concern themselves with every single thing going on in an additional binding, and also vice versa. The criteria that we or the requirements that we place on additional bindings to ensure that they are still eligible to be shipping in a Silk.net version is it must use our interop technology, so that's SilkTouch in 3.0, so that our bindings, whether additional or core, have the same general impression, look and feel. They feel the same to use, so it makes it doesn't end up with the library feeling inconsistent or designed by different people or whatever. It has to sort of implement the best practices that we are doing today, which in practice literally just means generate your bindings using SilkTouch and you'll be fine. So that's the first requirement. The second requirement is that it needs to be stable enough to be served to the Silk.net user base in a good enough state that they can start integrating into their work. Oh yeah, I should have mentioned this is basically a copy paste pretty much of the Silk.net community program requirements. Apart from the additional binding Silk Touch requirement, which is new for the additional bindings. But this stable enough to be served to the Silk.net user base. This is the same criteria with which we evaluate our community program projects. The next requirement is that the additional binding must serve a use case that the maintainers deem as deems as best served by a binding within Silk.net, and that it will be useful for building applications using Silk.net. So it's basically just it needs to be related to what Silk.net does. There needs to be more than just one specific user that would benefit from a binding. And things like that is basically evaluated by the maintainers team that the additional binding will be useful, and that it will be stable. And the bindings owners must meet all the requirements for the Silk.net community project maintainers. So that's basically, they need to be in the Discord, we need to be able to contact them, they need to be able to contact us, and whatever else. You can look at the Silk community repository for the specific requirements for that, but the bindings owners have to meet those requirements. Otherwise, we have to pull the plug on the additional binding, because we can't guarantee it will be maintained. And yeah, if in any doubt, look at the Silk community program requirements, because this is essentially a superset of the Silk.net community program requirements. Okay. And the maintainers will make sure that all all those requirements are being met. So, like, if we can't contact a binding owner, we're gonna get rid of that additional binding, or stop updating it rather. We go through the whole high-level utility thing I discussed earlier, where basically it goes through the proposal documents for a high-level utility that deviates from the native API. It has to have a proposal document that is submitted to the GitHub repository. It needs to have a meeting that is hosted in a public forum. So in our case, for the top-level working group meeting, it is Discord and YouTube. We don't necessarily require the additional bindings owners to use YouTube or use Discord, although they probably should use Discord. But probably to enable that flexibility, because not everyone has access to the .NET Foundation YouTube, and not everyone just needs to go through that process. But this is only for high-level utilities that are larger scale and that deviate from the native API concepts. It needs to accept comments from anyone. Again, that's the same thing as the working group meeting we're in today. Anyone that gives input into these meetings is considered part of the working group. The main requirement is that these meetings have to be recorded as well, so that if ever we are wondering why someone implemented an API the way they did, or where our mindset was in approving an API, we could go back to the recording and figure out why we did that. The bindings owners have to have a majority approval, and so there needs to be no one that's objecting to the proposal. There are some specifics there about what happens if someone objects and doesn't withdraw their objection even after changes. The Silk.net maintainer, only one Silk.net maintainer has to approve to attest that the proper process has been followed. If they don't agree with the proposal, they should have attended that meeting and raised their objections. But the idea is that these additional binding only self-contained working group meetings, as long as they follow our processes, they're going to land at a sensible API, provided that the interested parties attend. So the Silk.net maintainer, their only role in that meeting is to approve that that our processes have been followed. Because we don't want too much oversight into the additional bindings, because we don't want to suffocate them. But at the same time, we do want to ensure that we're following consistent design processes and following consistent design language with like the interop side of things. So it needs to use Silk Touch and whatnot. That's basically the goal here. Yeah, again, sort of net maintainers, it's bindings owners are basically left to their own devices. So sort of net maintainers only only shout at them, raise objections if they're not following the requirements set forth in this document at any point when they're designing the binding. Um, and yeah, the bindings owners will review and merge the pull requests that in their specific area without any oversight from the Silk.net maintainers. We'll use the code owners file, the feature in GitHub to do this. So we can set up a branch protection rule that allows a specific binding owner to approve stuff that's affecting their owned part of the code base. But if it goes outside of that, then the wider Silk.net team has to review it as well. Yeah, that's basically it. But yeah, the goal with this is that we will let additional bindings to be generated using our interop technology, so that's SilkTouch. We will let them use the Silk.net name rather than have to be an obscure secondary library. And as long as they meet all these requirements in the documents with how well known the API is and the maintenance approach and the design approach that they follow, then they're allowed to use the Silk.net name and get and be a lot more accessible to our user base. And if they don't want to follow one of these requirements, then there's always a Silk community program, which is slightly less discoverable, but it has more lenient requirements and doesn't necessarily have that same quality marker to our audience as well. But the idea with having such a well designed generator like SilkTouch is that we can have a consistent design language across even additional bindings that are maintained by a third party, and it still feels like Silk.net. And if it looks like Silk.net, feels like Silk.net, it's probably Silk.net. So that's the idea with this additional binding proposal. So I've talked a lot. Does anyone have any comments?
I
No,
have a comment.
Pretty much. Okay.
And it's just a question from the standpoint of us, because as maintainers, of under what circumstance are we willing to pull an additional binding, like maybe if it's atrophied for too long and is too far behind its intended, because just like maintainers flow in and flow out, I assume binding owners are eventually going to walk away from the project. Is there a point that we're going to agree that if it's not been maintained and is probably out of line with its actual original API so far?
Yes. So every single proposal that is passed by an additional binding owner, a Silk.net maintainer has to sign off that the process has been followed. If an additional binding owner is trying to pass a proposal, well, actually, no, scratch that. Sorry, if an additional binding owner is trying to approve a pull request, oh yeah, I see the problem there. Because we're not obligated to review their pull requests.
Well, and I'm not even talking about that. I'm talking about the case where the binding owner has left. They've decided they don't have the time for the project anymore, and no one steps up to fill that space. For a while, it'll probably be fine, but eventually, that binding will fall in quality and things as API gets updated, things change. Is there a point where we are going to say that we're pulling this binding? We're no longer going to be supporting this at all in our case, that until someone else comes along and redoes it.
Yeah, absolutely. So the obviously we reference the Silk.net community program requirements.
Yeah.
They set forth the prerequisites that are referenced by the proposal, and we basically say it's an ongoing requirement that you need to stay meeting these requirements. In terms of the maintainer leaving, if we if we aren't able to contact a maintainer, it says within 30 days after at least 3 attempts, then the community project is archived. So for the purposes of this proposal, after 30 days of not having a maintainer, then we would stop shipping the binding. And so that basically just means we'll stop updating it.
Yeah.
There is a sentence somewhere
That
in here
makes
that
sense.
says
Yeah, there was a comment about stopping updating. I'm just wondering if there's any point where we would choose to fully remove it from Silk.
from the repository. It's a good question.
Yeah.
I guess I guess it's kind of intentionally undefined. I guess now. But if we think someone's going to revive it, then yeah, I guess keep it in. But we'll have our own judgment there. I think. But
okay.
after that 30 days of not having a maintainer, then it's completely undefined.
Okay, that makes sense. I just wanted to make sure that that's where we were thinking of. Basically, it'll come to a case-by-case basis.
Yes, absolutely.
Of whether it stays. Okay.
Cool. Anyone else have any other comments?
I think that is pretty well fleshed out and fair and just. Sorry, my wife is playing Valorant, but yeah, I think I guess I have some questions regarding like, are there like versioning constraints? Like, how is it that like a bindings owner communicates the stability of any given release relative to what it's based on, right? Because like bindings themselves can introduce instability, and so just saying which version that you're linking doesn't necessarily tell the whole story. So I'm just wondering if there's like any guidelines about that outside of this document, or if there are any kind of sentiments that have been floating around in the hive mind of Silk around that.
Yeah, so I mean, there's this one comment in there that says binding owners are expected to be aware of the monthly shipping schedule. Additional bindings aren't going to hold up any library updates. Basically, we will snap with whatever is in the branch at that time, and the monthly update will be released as is. So if there's also this comment here that says binding owners are expected to keep incomplete changes on a separate branch using a branch prefix, which is allocated to them, and that uses we basically allocate them a branch prefix, and we configure our rule sets so that they don't have access to overwrite other binding owners. Well, yeah, whatever. That's specific. But yeah, essentially, whatever has made it to the main branch is expected to be shippable, and that's basically the only requirement. Obviously, in terms of keeping the native API up to date and making sure the bindings reflect the latest version, that entirely rests with the additional bindings owners. I would hope that they will listen to their users if they complain that that it's out of date. And I should mention that the meeting the prerequisites is it's again, it's an ongoing requirement. So if it becomes the case that they're not updating their binding, or it's become really unstable, then they would eventually fall foul of the of this second criteria here. An additional binding must remain stable enough to be served to the Silk.net user base in a good enough state that our user base can start integrating the additional binding into their work. And so that's probably the requirement that you're looking for. So that second criterion and that monthly shipping schedule sentence is probably what you're looking for the answer to your question.
I think I mean more specifically like related to like early stage bindings, where like maybe it's incomplete. Certain features may or may not be properly available or partially available, and so in a sense the binding would be like in an early access state.
Yeah, so that second criterion says betas and pre-releases are okay, but these must be coordinated with the maintainers team, so long as the primary advertised functionality of that binding works, so that it does what it says on the tin. That's another one that's inherited from the community program.
Yeah, I did.
But basically, it gets coordinated with the maintainers team. That's the main part.
I guess the laser focus is like, do you encourage the usage of like semverse suffixes like alpha or pre-releaser, things of that nature? Do you expect that? Because as a consumer of these APIs, I know that like I would want to see like very straightforwardly, if I were to be using an additional binding, that like what to expect in terms of stability, right? Like it could be labeled as a stable release, and it may very well be stable inside of these particular constraints or inside of what it provides. But you know, obviously, if it's like early stage or there are instabilities, I'd want that to be relatively front and center.
Yeah, and I guess we can put in some specific requirements there about version suffixes. I'd imagine with this betas and pre-releases are okay comment that we would probably ask them when they coordinate with the maintainers team that they will use a version suffix so that they're not it's effectively in preview, and has that suffix so that there's no false sense of stability on it. But yeah, it will be coordinated with the maintainers team, and I can add some specific wording there to clarify that if a binding is in preview, then it must be clearly marked as in preview.
All right, awesome. That's literally the only question I had for this proposal. I think it's pretty thorough, fair, just, balanced. It's good. Thanks.
Bailey?
And just a thought that kind of pings off of that is we probably, if something is in beta or pre-release, we probably do not want to add it to the main NuGet package. Just that way, if you're looking for that additional binding while it's in pre-release, that only goes to that specific NuGet package.
Yes, yeah, no. The instability of a single additional binding needn't infect the rest of the library. I agree. It should literally just be those specific bindings. Yeah, I agree.
Yeah. Well, what was said previously pretty much echoes what I think. It's a fairly well written out and documents what we've kind of had in our heads this whole time. There is one question from Aqua in the comments of YouTube.
Oh, yes.
30 days before time frame, the situations where life might catch up, maybe accessible for a while. It could be a bit longer.
Yeah.
Although after hearing what we were positive straight away changes things. Yeah, it is a bit short, but that's 30 days of just like no contact.
Yes.
Basically, like if a binding will generally survive without proper maintenance for longer than 30 days. Like it's not like it's going to bit rot immediately. It'll still continue working, and even with updates to other parts of the net, it shouldn't break in a bad way after only 30 days. It's 30 days of just full no communicado, can't contact them. And if someone does become busy and inaccessible, generally they'll give some warning, especially if they're like maintaining something like this. So I think 30 days is fairly fair.
Yeah, because like even just getting a "Hey, I'm busy" is communication back to us.
Yeah.
Yeah, it's not an unreasonable ask. It's just a Discord message, and they just say, "Hey, sorry, I'm busy. I'll get back to you in X amount of time," and then that's fine. That 30 days only applies to the no contact, and yeah, as long as they contact us, that is still deemed maintaining it. Like because. Well, they again because they're in contact, they can say whether something needs to be done or whatever. And when in the context of the rest of these requirements, like nothing incomplete gets merged into the main branch, then it in theory should be fine. As Bailey said, the binding will survive. It's literally just 30 days of no contact. Yeah, so I guess with just the version suffix addition, we can approve this then. Yeah. Sorry, remind me, Kieran, what your comment was. It wasn't anything to change, was it? It was just a clarification.
No, it was just clarification on what we were going to do, and it's vague for a reason.
Okay, excellent, cool. do I want to find the? Yeah, I'll find the pull request and put the comments directly on the pull request. April 12th, 2024. That was opened. Wow. Right. Put that comment there. I will update the proposal and merge it later on. Right. The next proposal is the first meaty one. So, although that was a lot of text in the previous one. So we're looking at Windowing 3.0. We have, so we previously took a proposal to the working group, me and Kai, for a new Windowing API. However, I think after proposing it, we both weren't really satisfied with it because there was a bunch. It wasn't really easy to make use of the sort of varying feature sets that we had in that proposal. So we go into a lot of background in this proposal. I'm not going to read out all that background, but the most important bit is that in Silk.net 1.0 we added an iView type, which was supposed to be a subset of iWindow, and iWindow inherited from iView, and that was basically as good as our write once run everywhere story got. Is that if you want your application to run everywhere, no changes, then you use a view instead of a window. Otherwise, you have to like type check everywhere, and we've realized pretty quickly that type checking functionality just isn't that clean. We actually realized this in Silk.net 2.0 when we deprecated iVulcan view, because what we observed from our user base is that having to type check is a lot easier. It is a lot harder and a lot more out the way than say having a nullable property. So in 2.0 we changed our Vulkan APIs in Silk.net to have a VK surface property on the iView, and likewise it's the same with OpenGL. There's a GL context property on the view rather than having to cast your view or window to that type. It's just, which we found made the varying feature sets a lot more discoverable. This proposal basically just takes that to its logical extreme, given our goals for the windowing API. So we want it so that instead of saying, hey, I want a view, I want a window, these are specific features I want, you instead query the Silk.net implementation for, hey, I just want an object I can draw something in, and then Silk.net gives you that object and says, oh, it also supports this, by the way, which is a slightly different way of thinking about it. But the idea is that you can check if, for instance, there's the window component on it, which allows you to control the window decoration and the and like window titles and borders and whatnot, or whether you want the OpenGL specific functionality. That's an optional component as well, and you use that by checking whether that component type is null. So yeah, but that's the main motivator, is that the iView and iWindow split, it didn't really lend itself to write once run everywhere, so we wanted something better. So we've got the concept of having a surface you can draw in. Yeah, does anyone have any questions before we get into the specific components of the surface?
Nope.
I guess not. I will plow on then. So yeah, basically a bare view that doesn't support any of the optional components is fairly a bare surface is fairly, it's fairly slim. There's not much you can do with it. You've got the drawable size, which is the size of the area you draw in. You can get the native handles of it, and that's pretty much it. So the idea is that we've created you a window. You can use the native handles to do something with that window if you want. The bare surface also includes the game loop thing, so the frames per second and the updates per second, and like the basic event controls, but that's it. But the idea is that a surface implementation will always support at least one useful component, and by making these components access through nullable properties, the user's IDE forces them to account for the fact that feature set might not be available on the surface if you want. So at that point, you can either choose to have that varying code, which again, it's encouraging the user to do the sensible thing. Or you can just decide, well, okay, if I access this feature set and it's not available, I want the application to crash, which is okay too. So, and that's basically how we've approached the optional versus mandatory APIs. The mandatory APIs are basically what is on the surface class, the top level class, and the optional APIs are nullable properties and whatever is contained, whatever is gated behind those properties. It's at this point I should probably note that because of this write once run everywhere, we've also got a different model for actually launching a surface. So if we scroll up, we've got the concept of an iSurface application, which is basically just having a pluggable main function. So the idea is that you call into you provide an initialization function. We provide you the surface as part of that initialization function. You set up the surface, you bind to your render events, your update events, whatever, and then once that initialization function exits, it's now entirely within the control of the implementation for making sure that surface is ticked often and the necessary events are run as configured by the user. And we have to do this because of handling the mobile versus desktop way of doing things, where not every platform gives you a main function, for instance, and requires you to subscribe to some pretty strict event rules, whereas you can't use a while loop. It's basically just you pass the native API a delegate that it calls whenever it feels like. And so we expose this in a way that is fairly innocent for the user. We've got an example here in the proposal where you have your program class inherit from an iSurface application, and where you do have a main function, you just call this iSurface application.run function that then calls into your initialization. Just while we're thinking about iSurface application, the way that this works for multiple windows, just to preempt questions, is that there is a children component that allows you to spawn a child surface, and it basically when that happens is that you have that where am I? So there's a spawn function, so it's accessed with surface.children.spawn, and when that happens, it sends that iSurface application to the backend. It will call into iSurface application's initialization function, and you set up your events like that, and then those two windows are running in parallel, or in whatever. Those two windows are open at the same time, and it's implemented in however is most appropriate to the backend, because there's loads of backend specific lifecycle rules. However, there are some cases where you don't. You do require full control over the surface lifecycle, and there are cases where, if it is available to you, then you do want that while loop rather than delegating control to the windowing implementation. Or likewise, it's entirely possible that unless you have that while loop, you don't want your application to work. And for this, we have the iDetach surface lifecycle interface. This was actually added in response to a comment that Kieran made, where essentially it is you have this try create method, which you can use to determine whether you can have that while loop, and if you can, you get this iDetach surface lifecycle objects that contains the surface that is created. It gives you a value that indicates whether you should stop your while loop, and then it also gives you a method you should call whenever is most appropriate for your application. And you should only call tick if should terminate is false, and that creates the while loop. I heard a mic unmute. No? Okay. That's the iSurface application stuff specifically. I just figured I would cover it while we're there. So does anyone have any questions with like the general layout before we get into the specific components? Obviously, we're not going to go through every single API, but because we'll be here for ages and you have your own eyeballs. But does anyone have any comments on the actual structure? I have used it and it does feel nice to use. So, but that I know that's kind of like the Obama medal meme.
The structure is pretty good. I definitely do agree that typecasting is very frustrating, and that the nullable component system is a lot better when it comes to C# ergonomics due to the special syntax for like non-null checking. I think it's very um, it fits a lot better into C#'s general usage than typecasting does, and as you mentioned, makes it a lot more discoverable, which is a problem we had in 2.x. So yeah, I think it's I do agree with the general structure of it.
Okay, excellent. So for OpenGL, it's pretty much the same interface as last time, obviously within the bounds of this component definition. So we have this IGL context interface that is in the SiltNet core interoperability namespace. Which basically it's an iNative context, so you can get a proc address from it. So we have something to plug into our GL bindings, so we can load the functions, and then it has some other minor information like what the swap interval is, whether the context is current. We also maintain a vsync property just for compatibility with 2.x. Well, not compatibility, but familiarity with 2.x, where if you're used to just having a vsync boolean, then we'll have a getter and a setter that automatically determines from the swap interval whether vsync is on. And you also have the swap buffers function, which you have to call as part of the render thing. And we still have the automatic buffer swapping as well. That is part of the, if we go down to the OpenGL component, which is exposed as iSurface OpenGL. There is still the should swap automatically, which will swap the buffers at the end of the render function, and that is on by default because it's something that pretty much all beginners forget. Yeah, and it's just an implementation detail at the end of the day. In terms of, we also exposed the IGL context source as well, which is exactly the same as it is in 1.x and 2.x, just in a different namespace, and it is implemented by the Surface OpenGL component. Yeah, we've inherited the version 32 structure from SiltNet 2.x as well, and SiltNet Core as well, because that's used for Vulkan as well. They use this as a first-class type in Vulkan and OpenXR and whatnot, so it does deserve to be in the interoperability namespace. And for the OpenGL-specific stuff, we've got the create OpenGL function as well that we had in 2.x, which functions exactly the same way as it does. So you just do surface.createOpenGL, and you get an instance of the the GL bindings for 3.0, and this is in the OpenGL assembly itself, using that interoperability type to find core. And for the rest of it, I mean, the configuration options that we expose are pretty much the same as they were in both 2.x and also what was in the original version of the Windowing 3.0 proposal. It's a common theme with this proposal is that it's basically the same APIs, we've just rejigged it a bit so that it's easy to access. And we also have an example of the usage. So here in this example, we're checking whether the OpenGL component is null. If it's null, then we're just crashing the application because OpenGL is not supported on this platform and we need OpenGL. But if it isn't null, then that means OpenGL is supported, and we set the properties on the OpenGL component. The OpenGL component, by any of these properties being set implicitly, enables OpenGL support for that surface, i.e. it creates the OpenGL context. There's also this is supported flag as well. This is new for 3.0 and probably a convenient thing for the user. So you can configure the OpenGL component. You can check is supported to see whether that OpenGL configuration is actually supported. And if it's not, then you can change the configuration or you can just crash. So in this example, we are setting the OpenGL version to version 3.3 with the OpenGL core profile. If it's not supported, then we're going to try OpenGLES, and we're going to try OpenGLES 3.0. And if it's still not supported, then I guess we don't have a high enough version, so we just crash the application again. And the idea is that after that, you'll have an OpenGL context by the time you get to the created callback on the surface. So you just go ahead and call that create OpenGL function, and then you do your GL stuff. Yeah, again, this is using that iSurface application.run in the main function. But that's generally what that's probably the best example for what a 3.0 application will look like using windowing. Any questions about that? I hear nout. Right. Yeah, next up is the window component. It feels weird to have a window component in windowing that's a component of a surface, but just bear with me. This basically controls the basically you've got the surface, which is obviously just a rectangle you can draw on, but the window component actually defines, well, this is a rectangle that is within a window manager, and exposes the controls that you will have for that window decoration, with regards to like the window icon as seen by the window manager, and you've got the window borders, so you can set up your borderless full screen or whatever, and you've got the window state as well, whether it's maximized, minimized, full screen, whatever else. And the idea is that if you don't care, if you don't care about how big your window is, or otherwise don't want to specify any information to the window manager about the surface that you're requesting, then you just go ahead and ignore the window component. You'll just get whatever you're given from the window implementation. But if you do care, then you can check whether this component is supported. And I feel like the most common use case for this would be if you're developing a game. Obviously, on mobile, this window component isn't going to be supported, so you can just assume that the window occupies the full screen. But obviously on windowing, on windowed operating systems, we don't want to assume the default is full screen, because that's going to get chaotic quickly. So you check whether the window component is supported, and if it is, then you configure the window decoration as you see fit. It gives you that extra configuration if it is supported, and if not, you can decide whether that's a problem in your application, but hopefully it shouldn't be. And yeah, other than that, it's basically the same APIs as last time. We have changed the positions and the sizes to use floats, just in case there's ever a windowing backend that supports fractional like sub-pixel window sizes, which is probably not unheard of with all the DPI craziness going on. But that's just a little thing, and it also means that, well, it's probably going to be quicker to do things in terms of those sizes and positions and whatnot. And this uses the Silk.NET Maths rectangle type to that end as well. There is an is-close requested on the window, which basically says has the user pressed the X on the window to ask it to close. And the way that this interacts with the surface lifecycle is that if the user hasn't changed this Boolean property back to false by the time the next window loop rolls around, then we will assume that it is time for the surface to terminate, and call the terminated event on the surface class. Obviously, if this is window decoration, this is Window Manager OS is specific. If you've just got a regular surface that doesn't support the window component, then the operating system terminates the surface when it feels like it. I.e., if the user swipes the app away on their phone, then that'll go into the pause state, which the top level Surface class does support. Obviously, if the app, if they go into their task switcher and quit the app, then that results in the termination function being called. But basically, the idea is that unless you've got a window, unless you've got a windowed operating system, you don't really have control over the application lifecycle because you don't have a window that you close. It's just you have a surface that was bestowed upon you by the operating system, which is why that's here. And then other than that, it's basically the same stuff as in 2.x. You've got your topmost configuration, you've got your window board, your window state, your window title, all that good stuff. And again, we've got a usage example. I didn't do this on every single component. I'm very surprised that I made it this far and still gave examples. But yes, there's some nuances around the window icon APIs because I hated the window icon API that we had in 2.x, and I tried to do something better, but it turns out it was pretty bloody difficult to make a nice API that is also efficient. But I did my best. Like with the triset icon, if you're using .NET 9 and C# 13, then you can use the lovely collection expressions to define your window icon variants for the various DPI sizes. If you're not using .NET 9, then you have to use this window icon variants struct, which is basically a ref struct containing other ref structs. And yeah, there's a usage example. You basically just, hopefully, a good application should just, if that window component isn't supported, it should carry on anyway, because like for most games you don't actually need to do anything with the window. Basically the only thing you'll ever do with the window is to set your window icon and maybe put it into full screen mode, and that's it. If you're running on a phone, your game still works, and that's the intention behind this design. Does anyone have any questions about that? Comments? Yelps? Go once, going twice.
Technically,
all right.
I have a lot of questions because I'm new here. But I'm soaking it in, and it looks good for my naivety.
All right. All right, cool. So the next component that we have is the displays component. So we've actually renamed this from 2.x. Instead of calling it a monitor, we have called it a display. This is just a nitpick because a monitor could mean like a performance monitor, for instance. In the previous version of this proposal, we called this a screen, but I ended up deciding that a display is probably better for this abstract surface API concept. So yeah, the idea is that you have this surface display component that is accessed using surface.display using this component system. And that lets you retrieve the display the surface is currently on, and the displays that are available that the surface is able to be moved to. If your underlying operating system doesn't allow the application to control which display it's on, then this available displays will only contain one display, and that will be the current display. And yeah, you can set the full screen video mode using this component, and you can also see the available video modes. You can get events when all the relevant properties change. What's in this iDisplay class interface, is that you've got the bounds of the display. We've got the work area. This is a notable improvement from 2.x, where we only provided the work area unless you looked at the full screen video modes, then you could see the resolution. Why did we do that? So we've got the bounds, and the work area is a subset of the bounds, i.e. the work area is contained within the bounds. The known video modes, in some cases you might not know the full screen video modes available to you unless the surface is on that monitor, and then it knows what video modes it can change to. So this is a nullable property, but if it's not null, then the idea is that applications can get a broad idea for what modes it can render in on it if it were to move to that display. And the idea is that this is displayed to the user in like a configuration UI or whatever. Again, that's all game specific stuff. You can get a colloquial name for the monitor as well. This is whatever is reported by the operating system. For example, in my case, it will be a string that says Dell AW, whatever model name it was. But it's a user displayable string. It doesn't mean anything to the programmer, and indeed you shouldn't rely on this value containing anything of note. You can determine whether it's a primary display. These are all things that we had in 2.x as well. We just rejigged it a bit. A display is equatable to another display, and it uses the there's a bunch of lifetime concerns that I clarified in the remarks, but basically that for the root surface, they will all share the same display object instances. And in most cases, that means every surface will be using the same display objects. It's only in the case where you're using idetached surface lifecycle, and for some reason you've decided to do that twice instead of using the children component, then it is undefined behavior. But that's intentional, because the idea is that I wanted us to be able to not have static state and have it so that the root common ancestor surface, that is what owns the display objects. So yeah, that's everything. We've removed the gamma property because primarily because it was removed in STL3, but the reason that they removed it is because modern operating systems don't really support it that well. So we've removed gamma. And we've another change from 2.x as well is that we now have a windowed full screen and an exclusive full screen. And this is basically just a convenience property for the user, so that instead of having to set the window border to a hidden border and set the window to the maximized state, you can now just use the the windowed full screen. Window state, and it implicitly does that for you. It's just a nicety thing. This was requested by Stride, I think. These are all a bunch of just specific, like, that make it defining the undefined behavior essentially. But yes, there we go. Is there any questions about that?
Not really. The general design does look good. I do have one tiny nit, and that is probably rename iDisplay.name to something that makes it more clear that it's a colloquial name.
Okay.
I was going to suggest display name, but that's not very
it's implied,
helpful.
yeah. No, I can tell you what we use in the input proposals. We use description, so that's probably better.
Yeah, because like display name generally would mean like not meant for programmatic use, but since this is a display, it's a bit vague. So I'm not really sure what the correct word would be to use here, but it probably should be specified in the name that it's a colloquial name that isn't meant for programmatic detection.
Okay, I think description makes sense and is in line with some. I believe, in this I might be wrong, but I believe Direct 3D uses description for the same concept.
Description would work, yeah. I think the failed name of description would probably be more clear.
Excellent. Cool. Any more? I don't hear anything. Alright, so we're on to the Vulkan component. This is basically the same API as 2.x. We've got, you can create your surface, and this is basically just where the native windowing implementation provides a proxy to the relevant WSI extensions in Vulkan, then it gives you easy access to that, so that you don't have to do your own if-defing for all of the relevant WSI extensions using the iNative window API. It's basically, this is if the underlying implementation of the windowing API provides a convenience method for going to the most appropriate WSI extension, then you can do that here. So that's what that VK that create surface does. It goes to the relevant WSI extension function, and the get required extensions as well. That gets you the instance extensions that you have to shove into your instance create info as well, and that's basically just a Vulkan property as well. You have to set Vulkan is enabled as well. The OpenGL does also have an is enable property, but we implicitly set it to true if you set any other properties on iSurface OpenGL. Where is it? Yeah, is enabled. Oh, it's actually determined by what the context profile is, but it's the same difference. Yes, so if you want Vulkan support, then please configure your Surface for Vulkan support. I'm not going to give anyone the opportunity to comment on that, I don't think, unless they scream, because this is really is pretty unobjectionable. It's exactly the same as 2.x, so I'll be worried if there are any comments here, but please correct me if I'm wrong. I heard no screams. Excellent. So the scale component is completely new. This provides better DPI awareness because this is just hell. Honestly, high DPI is so ridiculous. It took me ages to come up with this. But basically, the idea is that you have this scale component, and well, I can give you an implementation detail here. This is always supported on every single platform with the reference implementation today, but obviously that's not required. But yes, iSurface scale, it gives you a number of float properties that determine what you should scale your application elements by. So, for example, the content scale is the factor by which you should scale like your UI elements to make text readable. This is how Windows does their DPI scaling. So you render at full resolution, but then you have to zoom in your content depending on what they set in the Windows settings as to how big they want their UIs. Whereas macOS does it differently. macOS just alters the draw scale. Sorry, the pixel density. They alter the pixel density. Actually, no, they don't. Sorry, they alter the resolution, and you have a set pixel density. So if you go into your macOS settings and ask for I want bigger text, then it basically just lowers the resolution. That's how it achieves it, but it gives you that high pixel density, so you can still render a higher DPI, so that you're still maintaining clarity, even though it's got that virtual lower resolution. And then this draw scale is basically a combination of these two content and pixel density scale. You might say that just calling it draw isn't a very good name. I can already predict that argument, but the idea is that this is supposed to be like surface.scale.draw. So you already got scale in that call chain. And you're never going to use an iSurface scale without a surface. So I figured it was just a nice readability thing from my perspective. We can argue about the specific APIs if you want. But this is how SDL has defined their high DPI APIs this time around, and they went through a lot of effort to completely rewrite their high DPI handling as well to handle this. And so they've got a lot of documentation as well that we can probably copy into our own documentation to explain this further. Obviously, that's a big fat remark comment that should hopefully be helpful. But yeah, we're standing on the shoulders of giants here with pre-bike shedded APIs with this. So yeah, are there any? I suspect there might be comments here, but are there any comments? Oh, lovely. Nice and easy.
Sounds like it was probably a nightmare to work out something
Yes.
uniform for this.
Yes, every single operating system does it their own way. Honestly, it is ridiculous. And yeah, the STL documentation has tables of what different configurations on different operating systems likely mean in terms of these floats. So yeah.
I feel bad for them, but I'm thankful for them.
Yeah, they did all the hard work for us. Yeah. So the children component, we've already touched on this earlier, but yeah, basically you do surface.child.spawn, and then that iSurface application goes to the underlying implementation. That underlying implementation calls iSurface that implementation's initialization function, and then it's basically the same. This is just an aside, but this iSurface application thing, this is intended to make the surfaces embeddable as well. So if you had a UI control, for example, like in Avalonia or Uno platform, you basically would just pass in a iSurface application implementation into that type, into that like the XAML, for instance. You just refer to a specific implementation of iSurface application, and then the embedded control will call that initialization function and do everything. So it's the most embeddable API I could come up with. But yeah, that's just an aside. We haven't discussed any UI controls in this proposal. But yeah, you can't get simpler than that, folks. Awesome. Oh yeah, sorry, that silence was asking for questions. I appreciate I didn't say the words, are there any questions? Okay,
Thank you very much.
Yes. And the detached surfaces as well, we've already gone over this, but this was a Kieran requested thing, but I'm sure will be useful for other applications as well. Is that if you do want to run your own while loop rather than just going into the opaque backends, then you can do that if it's supported using this try create, and then you just call tick until should terminate is false. And yeah, that's it. It's that's the windowing proposal.
Do you have a question related to using the detached surface with the children? Because your children requires an iSurface application, but detached surface does not have a surface application.
So it does. It was I had to scroll a little bit to see it. But yeah, when you call try create, you pass in a iSurface application.
You'll still bet. Okay.
Yeah. And the idea is that if you've created a root surface using iDetached surface lifecycle, and then you want to create children from that root surface, it will fall within the same lifecycle. So like when you call tick on your iDetached surface lifecycle, it will call tick on the root surface, but it will also call tick on all of the children surfaces as well.
Children. Okay, sounds good.
Excellent, cool. At the end of the document, are we approved?
Yeah, I think aside from the one change of a name.
Yes, yeah, I will put that on the PR now.
Looks good to me.
Pull requests. Cool. Windowing. Cool. Excellent. So we're getting into the interesting bits now. The input proposals, which we have probably these have probably been the most scrutinized proposals we have ever had for Silk.net. I love it. But in terms of the actual base multi-backend input proposal, this was approved by the working group last time. And this is just making some changes to it in response to some feedback that we received. So the first changes that we're making is that we've updated all the examples and the APIs here with regards to the reference implementation to reflect the new windowing proposal. So not many changes here. You now create a input backend from a iNative window. So and what this means in terms of the Silk.net core interoperability types is that you just do surface.create input exactly as you do with 2.x. And there's also the create input backend function as well, which will create the native input backends. So if you do create input, you will get a input context that contains one input backend that is the default backend for that window. Obviously, you can then add more backends. Again, it's multi-backend input is approved last time. And you can also just create the input backend separately and create the input context from scratch later on if you want. It's flexible. But yeah, there's just minor updates to reflect the windowing 3.0 proposal. It's this was all approved last time, the multi-backend concept. One thing that is different though is that we have mandated that input devices are equatable to other input devices, and the reason that we've done this is that that a input. Oh, what was the reason that we did this? That was a really specific reason. Oh yes, right, yeah. So a object that is representing multiple objects representing the same physical device are equatable to each other, and it uses the ID property for that. Yeah. So other than that, we did some clarifications to the device property as well. Yes, so that the devices property of an input backend will only contain the connected devices. If it's not in that list, then yeah, it's sufficient evidence that the API has been that the device has been disconnected. And we obviously have the input handler that receives the connection and disconnection event. This is just some minor wording changes to clarify some comments when I think Dom was reading through it. Which makes sense. And there's some object lifetime considerations as well. Yeah, this was why we added the physical device equatable rule, is because it wasn't clear from a object lifetime perspective. Like, what if a device disconnects but then reconnects? It would do both objects work? Does only one of the objects work? So we clarified that every object that represents a physical device will be functional so long as that physical device is connected, regardless of whether you've disconnected, at which case we obviously forget about the previous objects, but if the user has kept this around for some reason, then it'll still work. It's just like a nicety thing, so that they don't have, if they're doing bad things, we will let them begrudgingly. Yeah, and the other changes here are in reference to the change in our mouse abstraction, and yep, there are no other changes, I think, other than the fact that, well, what I'm about to discuss. I'm just double checking. Oh yes,
strap in, everyone.
Yes. We also added a timestamp to all of the events as well. This was something that Lumi, one of the a Silvernet contributor, was going to propose, but then there was too many arguments about the proposal, and it ended up on the back burner. But one of the useful things from that proposal was that all the events had a timestamp, so he went ahead and carried that forward to this proposal as well. The timestamp is the stopwatch timestamp. Obviously, I can already hear Bailey's head whirring in terms of like the whole virtual reality future timestamp thing. I think the idea would be is that you define that in terms of stopwatch.frequency and map the timestamps in there, but that's intentionally left out of this proposal because it's nightmare fuel.
It kind of is, yeah.
Honestly, OpenXR is.
Unfortunately, there actually isn't a way in base OpenXR to map them back to real time. The XR times are completely opaque unless you have an extension, which I think all meter run times at the point, but that's kind of beside the point.
Great. We'll work it out if ever we had a VR backend.
Yep.
Okay. Cool. Oh, we've also added a button read-only list. This is just a convenience thing because we've changed the way that we do devices with buttons as well to make them more common across joysticks, gamepads, and pointers. Pointer and mice, don't worry about it. We'll discuss it in a bit. So that if a device supports buttons, then they implement this iButton device of T, which contains a button read-only list of T. and has the button input handler for the event handling as well. And the handler mechanism, if you want to learn more about that, then see the previous working group meeting where we approved this input handler design. But basically, our logic with having this button of T type is that button handling is basically the same across all of the button enabled devices. It's just the buttons have different name, so we enable that by having this generic type that implements an enum, and that's basically it. So we're getting into the interesting bit now, the pointer input. So instead of having a mouse class, which obviously only works with a mouse interface, which only works with mice, we had a request from the Stride people to look at, and Dom, I think they came in parallel, to look into abstracting our mice abstractions a bit more, so that instead of having a mice that you know is a mouse, you instead have the concept of a pointer, and a pointer is just this abstract thing that the user can use to point at something on your screen, on your surface, or just on a target. They're pointing at something, so we created this abstract API for getting a pointer device and seeing what it's pointing at. So the idea is that a pointer could be a mouse. It could it could be a pen. It could be a finger. Well, actually, no. It can be a touch screen, a finger device, touch screen device thing. So I guess to clarify that, I'll keep on going. So an eye pointer has multiple targets that the user can point at. It might not have multiple targets. The idea is that there'll be an eye pointer target for the touchscreen case. There'll be an eye pointer target representing the screen, and you can get how many points are on that target, i.e., how many user things are pointing at that target. So in the case of a touchscreen, you use get point count to figure out how many fingers are on the screen, and then you can get the point for each individual finger on that screen. Yeah, that's a valid comment, Aqua, in the meetings chat. So they've said that, for those that can't see the comment, is that they've said that it being called iPointer is somewhat confusing, given that it doesn't clarify it's a device, and people might naturally think of pointers as being code pointers instead of pointer devices. And I guess, yeah, you're absolutely right. I named it iPoint. I left out the device to be consistent with the other devices, so that it's not iJoystick device, it's just iJoystick. It's not iGamepad device, it's just iGamepad. And I guess we could make an exception here, or we could change all of the other ones as well. I don't know. What do you guys think?
That's a tough one.
Yeah, that is. Yeah. I think slight inconsistency in favor of less confusion is probably the better choice. Because for other stuff like iJoystick, iGamepad, the device is very redundant, but I think having that slight inconsistency is probably better than making the naming of everything else worse.
It could be an I don't know, iTouch, but that's not it, because it does a lot more than a touch would.
Yeah.
I don't know. No strong feelings, really. I think iPointer device does solve it. It's a combo breaker, but it solves it.
But then it's inconsistent, yeah.
There might be another name that could be brainstormed.
I feel like iPointer is the terminology that a lot of people will like. Calling it a pointer makes sense for that group of devices. I don't know if you're going to get a better idea, but I do think calling it a pointer device, even though it's not consistent, is clearer.
Okay.
Because again, joystick, you know that a joystick's a device. There's no other connotation that's going to live in. Same with a gamepad. but pointer, we already have classes that are PTR standing for pointer, so like there's already that name floating around in Silk. So
yeah,
all right, you
I
wore me
point
down.
at
We'll make an
things.
exception. Yes. Yeah. All right, we'll make an exception here and just call it I pointed device. I think it's a very good shout. Yeah, it will be confusing. Yeah, so yeah, it's a very, very thin abstraction. But it's the idea is that it's meant to be mappable into so many different pointer devices. So that if you've got a pen, that'll have that'll obviously produce 1 point for the pen. But that point has loads of different things. So also it has the position on the target that it's pointing at. So for a window, for a target representing a window on the screen, it will be where like a mouse cursor is pointing on that on that surface, or where it's where the pen is hovering over on that surface. The reason why it is 3D is mainly future proofing. But also so you can get like the distance of the pen where it's hovering, and that's also why we expose this 3-dimensional ray as well, so you can figure out like the angle that the pen is coming in out onto the surface at, figure out the distance, and whatever else. And that's obviously in the 3D case. For like where you've got like an iPad and you're using an Apple Pencil and you're just hovering the Apple Pencil above the screen, but you're not actually pointing. Yeah, and for things like that, we've also got pressure as well, and we got the target is pointing at as well. For mice specifically, I believe we go into this later on, but this will have 2 pointer targets. One target will represent the surface that the mouse is it will represent the surface that the input backend was created from, and then there'll be another target that represents when it's in raw mouse mode, where it's basically an infinitely large target that your virtual mouse at that point can point at, and there is a mouse specific interface for switching between the two. So there is some typecasting involved, but I think it's reasonable here. So yeah, it's the pointer device is very complicated. We've had over 10 hours of discussion on this topic alone, all of which are available in our Coffee and Codes on the .NET Foundation YouTube channel. But does anyone have any comments on this? I'm expecting there to be many.
Most of what I've said, I already said during the last Coffee and Code, so I don't really have too many comments about the current iteration.
Alright. Yeah, I feel like we landed on a fairly chaotic neutral API in the end. It's probably the best way you can describe it.
Yeah.
It's no longer chaotic evil.
We take it.
Yeah. All right.
At risk of saying anything more about it. So Lord knows I've exhausted my right.
Right. Yeah, so there are some specifics about the target point structs, whereas it's basically we don't have a try get point, it's just a get point. There's a bunch of like internal reasons for this, like primarily so that the vectors are in and registered. Just little things like that, but you can basically just check this is valid property to figure out whether the flags indicate that the target point is pointing at the target or whether it's not pointing at the target, and stuff like that. It's yeah, it's fairly abstract, but it matches it matches the abstractions that Stride had, but it takes it a little bit further with the pointer target concept. So it just makes it a little bit more abstract. But again, we've discussed this a lot. And we have the buttons. We've got a primary button. We've got a secondary button. We've got a button 3, which is middle button. We've aliased it there. And yeah, for pens we have the eraser tip as well. Don't ask why it's button 30. That's what SDL did, and I'm sure it had a reason for doing that. And again, that's an alias. So if it's not a eraser tip, then well, it's just a button 30. I would be amazed if there is actually a pointer out there with 32 buttons.
I've seen some very silly mice.
Yeah, I'd imagine someone out there has one. All right, and yeah, so this completely replaces our previous mouse abstraction, but there is still an iMouse for mouse specific configuration, and that's mainly for the cursor configuration. So yeah, see, Aqua, that's not. I don't see 32 buttons there. I see a lot of buttons, but not 32 of them. Yeah, the I shall post it. I shall view it for the stream. That is what Aqua posted in the Discord. Gotcha. If you actually manage to find a device with 32 buttons, I will be very impressed, Aqua. So yeah, there's still
we can make a virtual device with it. We'll make it happen.
Oh well, yeah, it could happen.
We'll make it happen. /threat.
Yeah.
Just attach a mouse pointer to the bottom of the keyboard.
Exactly.
Every keyboard button
is a mouse button.
Oh, it's beautiful. Zone-based keyboard input pointers. Anyway.
Oh no.
Yes. Anyway. So
no, give me one of those. What the hell?
Yeah.
Anyway.
Yeah. So there's still an iMouse, and this is primarily so you can still access the cursor configuration, and this is notably so you can set the cursor mode as well, which will change this new. Where is the iCursor interface? Am I absolutely insane, or was there like a current pointer? Oh right, yes, no, I remember how this works. Sorry, I'm sure the words are there, but I'm not reading them. Is that essentially, as I said, there are 2 pointer targets, but only one of those pointer targets will actually have points for the pointer. In the mouse case, and that is depending on that iCursor configuration, specifically the mode property within the cursor configuration. So if it's in raw mouse mode, then it has points on one target but not the other, and vice versa. It still works with this abstract target methodology. It's just that's an important point to note, given that there's a bit of mouse specific thing required to work. And again, this is expected to be relatively trivial for games, for instance, where you want to just at the start of the program, you get your input context, you look at the pointers. If that pointer device is a mouse, then you put it into raw mouse modes just off the bat. If you've got like an FPS game, and then after that you can continue using the abstractions as usual. And yeah, there's a bunch of mouse-specific things like a mouse has a mouse wheel, whereas other pointers do not have that sort of thing. Yeah, that's pretty much it. You can set the position. You can try and set the position if the backend has that capability. If it doesn't, then well, tough luck, I guess. But yeah, it's a very, very extensive write-up of this API, and we've had a lot of conversations between us, the people in this call, to land on it. I guess, are there any comments, having seen this after what must be a few months since we wrote this up? Any further comments? Oh, amazing. I'm so surprised.
What a relief.
I know, yeah. Yeah, there's some minor renames as well. We've converted the is confined property that was on iMouse, iCursor configuration in 2.x, this is now a cursor mode in its own right. So you've got a normal cursor, you've got a confined cursor, which is still a normal cursor, but it can't leave the window bounds. I believe it's useful for things like OSU. And then you've got the unbounded cursor mode, which is where it's you it's basically it's a raw coordinate that is based on deltas. And it's just unbounded by the window bounds. And there's also the hidden cursor mode as well.
Mouse without borders.
Yeah, mouse without borders. I'm not sure why the why the cursor flags are still there. I think that needs to be removed because that's not referent. Oh no, it is referent. No, it's not reference. Sorry. I've got it in diff mode. That's very confusing. But yes, I will make a note of that. Cursor flags need to be removed. Cursor flags remove unused. Okay. So yeah, it's there's a few. There's a lot of nuances with this API, I will admit, but we've all read this proposal and we've all discussed this proposal at length. I feel like we're at the point where we've ended up with the best API we're gonna get. So now we're on to keyboard inputs. There's a few changes that have been made to account for region-specific keyboards, but not too many. So we've got this try get key name property now. So we've clarified that the key name it relates specifically to a English profile of scan codes. So the idea is that if there's an English game developer writing a game, they can look at what keys are on their keyboard and have a best effort mapping of these keys into scan codes. And the idea is that if, for the purposes of displaying a user interface for change key bindings, you would use get key name to map those scan codes into an actual key. And the good thing about this is that while key names change across regions, usually actual keyboard layouts don't change that much. So if you have your game defined in terms of keyname.wasnd, then that will automatically map into the appropriate keys on the user's keyboard layout, and you can use try get key name to get the name of that key for display purposes. We've also added dedicated key modifiers as well, because we need to stop kidding ourselves that they're just not other buttons. The native APIs have special handling for keyboard modifiers, so it makes sense that we do as well. So you can see what modifiers were set when a key on the keyboard when a key was pressed, or at any time really. We've also changed the we've also changed the keyboard to use this common button device as well, and button input handler. So key name is just another type of button. It's a keyboard specific button. Because key names map into scan codes, we no longer need the key struct as well, because a key name is just a scan code. We've got some discussion about how we can better tackle region-specific developers in the future, because obviously key name is English oriented, and there are loads of possibilities we can do in the future, like introduce keyboard layout specific key name enums that cast to the English key name enum, or whatever else. We've left this out of this proposal as we figured it was more important to get region-specific keyboards working from the end-user perspective than the developer perspective, but there is still more that we can do here. We know this. And yeah, I think we have a comment to that end in the proposal somewhere. I remember writing something. So yeah, we're using this iButton input handler where T is key name, and we're just inheriting all that common button handling. And yeah, we've also got keychar as well, so we actually maintain the text state as well within the keyboard state, as we did in the original proposal, the original 3.0 proposal actually. So I should stop pretending that's a new thing. But this keychar event is called whenever there is there is a character added to the text property, and we've also changed key down and key up to just key changed. And this also allows us to report repeats to the user as well. So you can get the operating system intervals of whether that key is repeated as well, without it just having to set key down and key up, as I know this is a point of contention in 2.x. I think I've covered everything. Yeah, so key name is based on the USB HID specifications. That was where I got them from. There's also some non-standard ones as well, like a soft left and soft right. Those are the buttons well, back when phones had buttons, they don't have buttons anymore, seemingly. But if you look at the old school Samsung Galaxies, where they had the button on the left, the button on the right, and then they had the home button. That's what it is. Yes, yeah. There's that future improvement text I was on about. Yeah. So that's the keyboard API. Are there any questions or comments about that? Nothing.
It's awesome.
Thank you. I'm glad. There doesn't seem to be enough positive comments in this call. Yeah, most of this is the same as the previous iteration of the proposal, so yeah, it's fairly well understood. Cool. And I think for the rest of the proposal, it's just a minor addition. So yeah, gamepads is we've now again, we're doing iButton device to make it common. We've again changed to use that iButton input handler as well, so that it's we're inheriting those events for the input handlers. Yeah, it's the rest of the API, as far as I can tell, is exactly the same, exactamundo. And yeah, that's the input proposal, it looks like. Oh yeah, we've added a clarification comment for changes to the states that they're in timestamp order, and timestamp is time, things like that. But yeah, is other than the pointer device API, the changes to this proposal, the previous approved version, are fairly innocent. So are there any further comments on anything that you have seen so far, or don't understand, or want more clarification on, or literally anything? There is not, it seems like. So that leads us into the... thankfully, I'm going to stop talking now. I'm sure you've all heard enough of my voice. But Dom has been a big influence in the input API, because they've helped us realize that there's a lot more abstractions that we could be doing, and just making the API more usable and more just more applicable for a variety of different use cases. And one of the ideas that we settled on pretty early on is that we eventually wanted to get to the point where you can consider everything an input and axis, like just an abstract axis of some description that you can map into whatever you want, that is just a floating point within a range, or whatever else. So we obviously couldn't do this as part of the base proposal because it was a lot to commit to, but the eventual idea is that you could use a low-level axis API like this to define like virtual input actions, because I know that someone's asked for an input actions API in the past, or you could implement the interfaces defined in the base proposal in terms of this everything is an axis proposal. So this isn't necessarily targeting the first release of SignalNet 3.0, although it depends on how passionate Dom contributes. But it's an extension proposal that defines this everything is an axis idea, and for that, I am going to hand over to Dom.
Yeah, so why don't I share my screen if that's all right, just to kind of
That
keep,
is all right.
the pace of things. Here we go. That's the one. Yeah, we'll do 60 FPS. We're gamers.
Yeah.
So there's a lot here. Uh, on a very high end level, you could kind of consider it to be like the Vulkan layer of input. But the idea is that by doing that, well, one, that layer should be mostly invisible to any users of SIL, unless they don't want it to be, in which case it's there. But two, it allows us to do things like, well, actually, I have a bunch of goals here, where we could like make the inputs more modular, like have a lot of like common code for like higher and lower level functionality. So then any input backend, any custom device or that you want to support, whatever it is, like doesn't necessarily have to reinvent the wheel and reinterpolate values and do all this stuff. It's just give us a definition of the device. Like, what is it? What are these buttons? What are these values? And the rest should kind of just do the thing. That's kind of the idea. Uh, so hopefully that paves the way for not only like input actions, but also like accessibility features that are kind of like free. The idea to create that you can create like a virtual gamepad in your game and like not logically treat it any differently from an actual gamepad, things like that. So did I miss anything in the goals that is significant? Nope. But yeah, so with this said though, that level of modularity revealed itself to require a lot of requirements that aren't straightforwardly enforceable by like the code or compiler itself. And so we'll go into that as we get there. But just fair warning, it kind of called it the Vulkan for a reason, but don't worry, it's not as bad as Vulkan or as good as Vulkan, depending on your perspective. So it does kind of rest on a bit of a modification to the multi-backend input proposal, but it's very kind of like low-hanging fruit. Basically, just adding description, status to the input device, just for the sake of having like end user facing information or developer information as to what's going on with a particular device, as well as like an additional Boolean property just to declare if it's virtual or not. That way, if you're ingesting input devices in your application, you could see and filter based on that, if it's virtual or a literal physical device. This could kind of allow you to create virtual devices as your like kind of even base input mapping layer. But we'll get more into that later, or not actually, not so much, but important field to have. But yeah, just to lay the foundations real quick before I take a pause. Basically, the core of the API is the concept of like an I-axis device. It's literally just a collection of axes paired with like definitions of those axes. Axes are like, what's their intended use case? Where are they on the controller? How do they relate to other axes, etc. All axes are, of course, just a single floating point value, ideally from 0 to 1. Not strictly required, but is a goalpost. And there are different flags that you can set describing whether or not your particular axis does not fall neatly within that 0 to 1 range. But because of all this too, much like Vulkan, we need like a device validation layer, which is going to be implemented if this is accepted in the input context. So it should again be like pretty invisible. It's more like of a developer tool if you're developing a backend that's implementing iAccess device, then you'll get nice little exceptions saying what you did wrong, which is inevitable because it's a lot of words to juggle around. But once it's right once, it should just be right forever. It's a matter of just lining up all your definitions nicely. So before I actually go on to like the meat and beans of code, does like the general concept kind of just make sense? I'm going to take silence as a yes.
Makes sense to me.
Great.
I think it makes perfect sense, personally, as an unbiased person.
Me too, actually, now that I think of it. So yeah. So device validation, also just more on that. There's going to be a publicly accessible way to do that. So if you have your own little input context implementation, you'll be able to use Silk's version of it, just because it's going to be pretty complex to actually implement. And there's no reason to reinvent the wheel. Though if you want to, by all means. Or if you don't want to validate anything and you just want to, you know, let freedom ring, good luck to you. You could do it. But yeah, so here's what the iAccess device is on the most fundamental level. Basically just being a collection of input axes. It represents a single input device, physical or virtual, that's comprised of a collection of floating point values. Should I make this big?
Yeah. Thank you.
Make this big. No problem. And F11? Nah. Doesn't make a difference. What if I close that? Whatever. But yeah, so it's got access descriptions. It should really be on top. I'm not sure why it's not. This is basically just this particular floating point value does this thing. This is how, on the most fundamental level, the device is defined. Axis groups. This kind of defines like groups of axes. For example, if these 4 axes make up a joystick, that would be like an axis group. Or if these 4 axes are a D-pad, that's an axis group, etc. And last but not least, or last and least, we have the raw values collection, basically just being, if the input from the backend isn't necessarily a normalized value, those values can still be accessible to anybody who wants them via this raw values property. And then whatever is accessible as like the iRead-only list interface, and in most contexts, it would be the normalized value. Makes sense?
Yep.
Any feedback so far?
None from me.
Great.
Yep.
So next up is the iAccess input handler. Much like how gamepads and keyboards and whatever work for accepting their input, we just have a struct with information basically saying, hey, this axis from this device has this value, do what you will. Most people, again, won't really be using this unless they want to. Well, actually, I don't know. I'm going to bite my tongue on that one retroactively. But
yeah, I think I think what you mean by that is that most people won't be using the Axis device. So for instance, the input context, if we do implement the iAccess device mapping to the high level interfaces, then the input context would receive this event and map it into something the user actually cares about. Yeah, it's a fairly,
that would be the most common.
Yeah, this is a fairly niche API.
Yeah. Though it does depend on what happens with the input actions API and what that looks like.
Yes. Yeah, absolutely.
We'll see. So yeah, access descriptions. So this is just like a struct that describes a single axis. You know, I'm hitting the X button on my controller, I'm hitting the W key on my keyboard, I'm pressing up on the analog stick. That axis is what it describes. And so it has a number of fields. First is the index. That index is literally just the index of the iRead-only list up here that it resides in. As kind of awkward as that is, it's only awkward once, and it allows us to do a lot of nice little clever indexing tricks. And so we love this, but do speak if you do not love it, in which case my brain might explode, but I'm accepting of it. Axis trait is a enum or flag that basically says hopefully all that we need to know about the axis, give or take, at least descriptively, like how it physically behaves. We also have a name, a Boolean for if it's available, which in most cases is going to be yes, but there is a newly added as of literally today, kind of like dynamically populated axis concept we'll get into. And so that could be false, or if some implementation wants you know, if you want to be able to disable a specific button on a gamepad, let's say you have a virtual gamepad implementation and you're adding and removing buttons or whatever, you know, that could all be right there. That's something that you can modify at runtime, because it's not part of the validation process. It simply states if it's available to be used. And then there is the raw value bounds. This is how normalization occurs. If it's the default value, we're just assuming that whatever axis value that we get raw out of the backend is just going to be between 0 and 1, and that's that. I imagine that's the case for, you know, most gamepad APIs and things of that nature. But for things with less standardized, I guess, outputs, here you just define the bounds of those values. Yeah. And then, of course, there's this little description method. Because this is a read-only struct, if we want to change the is available status of our axis description, we just make a copy with a different available value.
Yeah, just a comment there. Are you aware that the C# with keyword work exists?
Yes. But it's not true. Does that work for like no, actually, yeah, I guess I would just do it. So we might not need that at all.
Yeah.
That's cool. No, I'm gonna note to self, or if you want to leave a comment, because the less noise this proposal has, I think it's better for everybody. Yeah. Any questions on that so far? Haven't really gone into the traits, which are the meat and beans of it, but makes sense. Aqua says this looks very neat. I did something similar with my engine a while ago, except this actually had thought and knowledge put into it. I don't know about knowledge, but certainly more thought than I think either of us could really stand.
Yeah.
But yeah, so I guess let's go into the actual traits, and you guys can share in the pain in a good way, because it has a lot of built-in consideration. So hopefully you don't have to consider any more than you have to consider. But yeah, so these are the primary flags through which an axis's use is defined, right? So this is basically what is the axis, period, the end. Sans the bounds. Most of this we want to be able to provide default implementations depending on the behaviors. That becomes more pertinent once we get to axis groups. But yeah, let me go through this and you'll kind of see why. So we have a number of them. Obviously, unknown is 0, basically default or null. If an axis is left with this trait, we're assuming that it is ill-formed, and so it'll be either an error or ignored or what have you. You know, so the foundational traits that any given axis would probably have is analog or binary. I think for many that might be self-explanatory, but what it means is it 0 or 1, or is it 0 through 1? And then for things that are less clear, like in a physical sense, like let's say you have like a switch with like 5 notches in it or something, that's kind of open-ended as to whether you make those 5 notches a single axis and it's just analog, or you make it a series of binary axes, which is probably easier to deal with in that particular scenario. But yeah. Then there's a lot of physical traits here. So some axes might be related to the position of something like a joystick or a touchpad or a I don't know if it's like a Wiimote. Well, actually, I guess that's mostly gyro, but they have the IR. Regardless, there's point, which is like a position. This is something like a mouse, something that doesn't necessarily snap to center. It's like a point, like, you know, a coordinate point, sort of was the idea. Again, maybe my ordering is not fantastic. I don't know why this is up here. But in contrast to that, we have position, which is something that's kind of expected to rest in the center, more or less. It's like very cleanly normalized. Is it actually? Yeah. Why is it orientation? Yes. So orientation as a concept. All right, let me back up. Maybe there's a reason I put it there now that I mention it. So yeah, there's point, that's a position, just a position. Next up, we have the physical orientation related stuff. Orientation here as a enum value refers to the fact that this particular axis is related to the physical orientation of something. It's not just a button. It's something that moves. And so it's marked as analog as well, just because anything that's position based isn't going to be binary. And you'll see that pattern continue to go. You know, point was analog. It also has a raw value, right? So you can get an absolute, like in the case that it's like a mouse, you can get the actual mouse position versus like a normalized position, things like that. So orientation is similar in that it's analog, and then rotation is similar in that it is orientation, because orientation doesn't say much about anything other than it's kind of like situated in space, and rotation specifies this is a rotation. So with that, there's of course different types of rotations. There's Euler angles and quaternions. Where did the quaternion one go? Oh no, okay. So if rotation is not marked as a Euler angle component, it is assumed to be quaternion. And the reason why this is specified here is that a single quaternion axis is not really useful in and of itself, though you can kind of like figure out, oh, it's not Euler angle, it's probably a quaternion. There's really no reason to refer to a single quaternion axis if that's the axis that's defined. There's acceleration for like accelerometers. There's position, which is raw values in meters if it's world space, in pixels if it's screen space, etc. But the normalized values are, of course, required if the bounds of the positional space is known. If they're not known, then you need to use this raw value only flag. The rules begin to get pretty big. This is probably the most technical part of it because it's so kind of abstract and low level. But
yeah.
Next up is, well, actually, I should probably stop there because that's already quite a lot. And I imagine I'm just kind of skipping around mentally and missing some things that aren't clear.
It's useful skipping around though, because I mean, if when I end up writing the documentation for all this, I'm basically just going to watch this recording back and figure out where your brain went. So Yeah. I mean, obviously, I've been working with you on this proposal for some time, so I've it makes sense to me. So but I'm hoping the others have comments to try and determine ways that we can make this more obvious.
So
I guess
far, I'm following, so I'm not having too much issues.
Okay.
Yeah, I think I
That's
follow
good
as
news.
well.
Excellent.
Awesome. I do have a question to field to the audience, though. Just in terms of like default units, I think that should be defined in the case of Euler angles. And do we agree with degrees or radians?
I would assume
Generally, I use
radians, just because that's usually what if you go into any system math and you're going to radians first.
Yeah.
Yeah, there is also like floating point accuracy concerns with
That's what I was thinking of as
degrees
well.
because floats are more accurate towards 0. So
Yeah,
I think
I'm inclined to
radians
agree.
is probably good.
I like that. If we could make a note of that, I'm not prepared to take real-time notes. Yeah, it makes sense, especially as a lower level API, and higher level APIs could, math.2rad, whatever it is. That would be in radians. So I guess this would be 0 to 2 pi. I don't know the alt codes for pi, unfortunately, off the top of my head. And yeah, so it's required that you don't set the raw value bounds if this is applied. However, it will be assumed to be between 0 and 2 pi. I'm also flexible on that. I know like negative pi to positive pi could be a popular choice. But I do think that no matter what, we should have the API expect that the value is in range, and any like modulo operations or whatever wrapping that needs to be done is done prior to normalization.
Yeah. The negative pi to positive pi versus 0 to 2 pi. I probably don't have enough input experience to define which one's better.
Nor I.
I don't know what's better for the common operations you probably do for this. Because I mean, floating point accuracy is a concern, I think. And that.
Yeah, you do get the free bit.
Yeah, exactly. So maybe negative pi to positive pi is better.
Works for me.
Awesome.
Okay. So acceleration. Acceleration is another one that is raw value only because it's not something that really can be reasonably normalized. And yeah, there's also the concept of like delta. If you want to mark something as a delta, you can do so for things like a mouse, or if you want to do your own like acceleration measurements. I don't know. Yeah, you could do it if there's an axis that specifically pertains to deltas. Now, that doesn't have to necessarily be a literal hardware limitation, like the scroll wheel only works in deltas or the mouse only works in deltas. If you want to make a delta for something positional or anything, really, there's no reason you can't put an axis that's dedicated to that. That's pre-calculated, all nice and normalized, I guess, to the extents that are provided. Note that it says has raw value because the raw value would be provided in this case, or would be expected to be provided, but it also can be normalized. And so in things like a first-person shooter, if you're moving your mouse, that could be DPI aware, it could be resolution aware, screen aware, whatever. So even if that cursor is technically like locked to the center of the screen, you have like a meaningful DPI aware movement scale thing. And then there's also delta only. So this flag just basically says, I don't got nothing but delta with regards to this. And there's only a raw value. It doesn't make sense to normalize it. The use cases for this would be very niche, or they could be certain mouse position implementations or trackpad implementations or things of that nature. Okay, before I get to dynamic, there's also left and right side, because the idea is, hypothetically, an implementation could exist that just basically flips your symmetrical controller around, or maybe you want to support, what do they call it in Call of Duty world? Southpaw, something like that, controller configurations.
North Paw, South Paw.
Or if you want to, I don't know, there's definitely, I think, a lot of accessibility or gamer related use cases towards designating, at the very least, like left and right of a lot of these things, especially considering how symmetrical a lot of our input devices are. Even like a mouse, for example. So that's there for that reason. Not required, but it's nice. It's nice of you to do, potentially, for some system that will potentially one day make use of it. Last, and certainly not least, is this concept of dynamic axes. These are axes that are added at runtime, and I think the simplest use case of this is like a touch screen that has multiple touches. And so, barring the very specific recommendations here, it'll behave like any other axis. It just has to belong, if it's in an axis group, it has to be in a specific like dynamic quote unquote axis group that's added at runtime. The idea is that these things still maintain their indexes like throughout their lifetime like anything else would. So hopefully dealing with them isn't like too difficult. But yeah, that was just added. So then like, let's say a device supports like 20 touch points. You don't really need to define that explicitly 20 times. You could add them at runtime when they're there. Okay.
What happened to like 29? Because I see it goes 27, 28, 30.
Yeah, I don't know. I don't have a good answer for that. Because this basically I went to delta only was 27 because there was a skip between this stuff. I went up to 24. I don't have great reasons for anything, and I'm flexible on any of these numbers.
I mean, the individual bits don't really mean anything outside of the enums that they're assigned to. So in that case, they can be anything, I guess. Yeah, I mean, we're only, it's only ever going to be us in these meetings that define what the other bits are used for. So I have no strong preference either way.
Yeah, I would just sequential, just so it's easy to add new ones and easier to read.
Yeah, just totally sequential. I was trying to kind of like separate quote unquote system values from like user facing more significant values, but it really doesn't matter. Just keeping a lot of things
like
sequential
system
makes
values.
sense.
You could do like system values go from 0 up, and the other ones go from 31 down. Or I guess in this case it'll be 63 and down because it's a U-long.
Yeah.
So that they'll eventually meet in the middle, which hopefully doesn't happen. It'll keep separation visually.
Yeah. That is kind of what I started, and then we changed it to U-long, and then I also added things in the middle. So I like that idea. The old enum sandwich.
Yeah.
All right, I'll add an enum sandwich to my to-do list.
Yep, I've added a note.
Oh, thank you. So, I mean, we can get into basically what actually making these things looks like for your device. Like this is like a pretend DualSense controller, where there's this like, oh, nice typo. But like there's like a static list of axes, and then the instance will actually, oh, I really typoed this bad. But the instance would actually do this, where you have like an iRead-only list of axis description, say iaxis device dot axes is axes or something. Maybe this would be defined below, but this is basically how you do it. You know, the first one, index of 0, right? Because the constructor was there. It would be nice to have some IntelliSense here, little hover things, but yeah, it would just give like say the left joystick X minus. We'll give it analog, and it's on the left side. That's really all it is for a joystick. You know, it's nothing special. It's just an analog input. We'll do that for the rest of the analog stick, and then for the press, and for, let's say it has like a capacitive touch, which I think it does, we'll just add binary axes there. And then that keeps going. For things like the touchpad, this was not made with the dynamic API, as that was invented this morning. But you could see that hypothetically you could just kind of like pre-fill these. And if it's a position, using the axis by itself, if it's like pre-filled, won't be the best way to do it. We'll get to axis groups later, and that sort of information you could work with, like touch pressure and stuff like that. But that's here. And so on that note, there should also be like something like new 29 axis trait dot analog touch pressure 1 or something like that, and then on and on. That would go for 1, 2, 3, 4 if we're only supporting 4 points. That way you can have the position and the pressure is separate, and then you could also assume if the pressure is 0, there's no touch there, regardless of what the position is. But axis groups will be more useful for that. And then, you know, start, home, every other button and whatever. There's gyro and accelerometer, which is a bit more fun. Again, you're just kind of using that axis trait, which is predefined with what's the minimum necessary information. And it's just, for all of these really, is assuming default bounds. And then for acceleration is assuming no bounds, because the axis trait definition says, thou shalt not have no bounds on my accelerations. And so we follow what they say. We're good citizens here at silk.net. And so, yeah, this makes sense so far.
It does, yeah, I agree.
So lastly, I guess, you know, just to kind of, as an example, you know, you could have some fun stuff too. You could have like battery level, microphone level, whatever. It's not all the fun stuff. It's just an analog thing. Consuming APIs can figure out what to do with that if they want to. It may not also just not be user facing. It depends. And here's an example of the like a DualShock 2 controller whose like face buttons are analog, which is a little bit of a different, a bit rare. And so like you can mark something as both binary and analog. That is perfectly valid. There are just distinct rules for, you know, based on the dead zone provided, or not dead zone, I guess the range. If a dead zone is provided, that API coming later, it will use that. If it's not provided, then it'll just assume if it's greater than 0, then binary would equate to, you know, true, or on, 1. Otherwise, it's off. And then it could also be analog. And I'm very much looking forward to whatever sicko wants to do that for the PS2 controller. And whoever wants to support analog keyboards, that would be awesome.
Oh, so many axes.
So axis groups refer to, yes. I think we're ready for axis groups.
Yeah.
Am I going too slow here? What time is it? 4:27. I'll try to speed it up a little bit. Yeah, so axis groups basically is just ways to group axes. You got 4 axes in a joystick, it's an axis group. That axis group is marked with a purpose, and it has a list of axis indexes, axis indices, axes. In addition, it also has something called a twin index, which is useful for, like let's say I have 2 thumbsticks, swap southpaw as well. It's not necessarily left or right. It's the same kind of concept as left and right, but it pairs it to an exact other axis group that will allow you to like swap those sorts of things with a straightforward API in the future. And then yeah, name index works the same as before, and everything else that will be discussed, just reference to the collection that it originates from. And yeah, does the concept of an axis group make sense?
Yep.
Right. So now, yes, we go into types. So an axis group type is the enum. It's how we define our axis groups for what they mean. We have several of them. Of course, unknown. 4 face buttons like triangle, cross, square, circle. A B X Y, B A Y X. Whatever Nintendo soft you're from. And then we have different joystick parameters. Joystick 1D, 2D, 3D. Most use cases will be 2D, of course. And notice that like these flags have built-in interoperability, right? So like if it's a joystick 2D, it's also a D-pad. If it's a position 2D, or it's also a position 2D rather, which is expounded upon later. But basically a joystick can additionally be used as like something like a cursor. The user might be fighting a bit against it recentering itself as soon as they have to scratch their nose, but it's there. And so, yeah, all of these sorts of like quote unquote inheritances are sort of built in for all of these sorts of things. Most interestingly, out of this, I mean, there's a bunch of specific stuff like device information, the whole dynamic and left-handed, right-handed thing is here too. But the most interesting is that this kind of like sets a standard for how certain data types are handled, namely like positionally or rotationally. It has a standard for like axes that is described, I think, more in depth below, but also here. So basically there's an ordering convention. Negative x, negative y, negative z, positive z, negative w, positive w for all the 4-dimensional beings out there, or quaternions, same thing. And that kind of goes throughout. So even like for 4 face buttons, your axis group needs to be defined in order of, in the PlayStation example, cross, triangle, square, circle. Bottom, top, left, right, and then like in, out. Fortunately, my mouse is only 2D. And that is kind of followed throughout. So joystick here is, yeah, I don't know. I was going to actually say an idea, but I'm going to save myself from that because it could be a rabbit hole. But yeah, for rotations, it's the exact same thing. Rotations, I think, are more commonly, it's going to be 3 axes. I was entertaining the idea of 6 or 8, similar to how joysticks work. but I think 3 is going to keep everybody nice and sane. And then quaternion, of course, you need 4. And then W at the end, like I said. And yeah, that's the groups in a nutshell. The logic surrounding them, again, hopefully no one ever really needs to use, but these are like the definitions that allow an extremely like reusable higher level utilities to be built on top of like any device, basically. If something's supposed to act like a joystick, you can act like a joystick. Yeah, any questions?
I don't think so.
Great.
I know, this is going swimmingly.
We just have smart people in the chat.
Yeah.
This is my first time seeing this. I'd be spinning a bit, but I'm glad it's not. I'm glad I've been staring at this for God knows how many hours. So this is more on that directional convention. I just kind of wanted to provide some concrete examples and like kind of leave nothing up to interpretation and writing. And so I mentioned, left, right, down, up, backward, forward, etc. That being the convention. Like for examples, just a standard D-pad, left, right, down, up. For a joystick, -X, +X, -Y, +Y, left, right, down, up, blah, blah, blah. Now, GameCube is a bit different and might fly in the face of what one might expect given the following consoles and even preceding consoles of Nintendo. To me, it is very important that it is physically defined in terms of like the axis group, right? And so in this case, it would be B as the leftmost, X as the rightmost, A as the bottommost, and then Y as the topmost. That would be the most fitting axis group organization, like just in that order, in that like array of axes. That would be the one. And then, of course, we mentioned PlayStation. How many times Sony should give me a raise or hire me first and then give me a raise? We got Nintendo 64. This is, we can start to look at some of the power and flexibility that this can give, I don't know, users. Basically, you could define multiple axis groups or multiple axis groups to a single axis. And you could, in the same way, you could define multiple like axis group types to a single axis group. It's very modular in that way. And so here with like the Nintendo 64, I could say, okay, yeah, primarily these C buttons are like an axis group in themselves, left, right, down, up. But also, it's not uncommon for B and A to be a part of like a directional control scheme as well. And so I could say as like a secondary axis group, there would be B down on the C, A left on the C, which kind of creates another directional pad in a similar way to like a PlayStation controller or whatever it is. The great diamond of gaming. A keyboard WASD. I think you guys get the picture. I just wanted to make sure that like there's like a proper reference for how we actually order these things because it is pretty important. It carries a lot of the weight of the modularity of this API on its back.
What's the handedness of the XYZ for the accelerometer? Is it Y positive up, Z positive forward, or is it like Z positive negative? Or
now my thoughts for everything was that like Z positive would be forward. Y up would be up, as we mortals understand it, and X positive would be right. just as a layer of consistency. Now, if that flies against the conventions of like more prominent Silk libraries, like that's open for discussion. I just think that seems the most intuitive to me.
There pretty much isn't a convention. OpenXR, for example, uses Y positive up, Z negative forward. I know some other things use that as well. I think Blender, if I remember correctly, is Z positive up, Y negative forward.
Yes.
And then it's a complete toss up for pretty much everything. For what axis convention is used.
I mean,
so
if it remains
kind
a
of isn't
toss-up,
standard.
Industry-wise, there certainly isn't. And if you guys haven't really decided on a standard, I feel pretty comfortably in the, left to right, negative, positive, back to forward, negative to positive, down to up, negative to positive. That just seems intuitive and consistent to work with. But
Unfortunately,
I'm
graphics
open to
APIs
different.
themselves also don't agree.
Yes.
So
Graphics
Silkline
APIs don't
by
agree.
default, yeah, Silkline by default will not agree with itself, and there's kind of nothing we can do about that. So I think we
Yeah.
kind of just have to pick one which seems the most reasonable, and just hope and pray and document it well.
Yeah.
I think the most common that I've seen is Z negative forward, Y positive up, X positive right. That's what I most commonly see. Is to have Z negative be forward.
I see the case for that. It just seems like a combo breaker mathematically when dealing with a lot of this. But I could be wrong.
It does that usually because that's the assumption that the screen is basically going into the screen is going back behind the screen versus coming out of the screen.
Yeah.
So it could go either way, and I don't think like we just need to make a decision, and I don't think it really matters.
Yeah.
Just be consistent about it.
Yeah.
I mean, it's a valid concern. I was wondering about that too, and I kind of just assumed that it was a eternally undecided thing. So I made a decision that sounded the easiest to wrap my head around personally. I think it's probably the easiest for less experienced developers, and also probably not a problem for more experienced developers, though it's just an additional thing that isn't quite matching anything else. I guess such is the case with Axes.
I think for newer developers, the important thing is that it matches like what Silkline.maths does, and what the most common API is going to be doing. So I think basing it off of like what's DirectX doing in this case. I'm not sure. I don't really use DirectX.
DirectX has functions now for both left and right-handedness. So
Cool.
yeah, they let you choose. OpenGL has specific, well, and technically, though, if you're doing shaders, shaders for DirectX is going into the screen as positive.
Into the screen is positive.
Because it's 0. So it's... Yep, 0 to 1.
Okay.
With 1 being basically in your face.
No, 1 being your far plane.
Oh, okay.
0 being your near plane.
Got it. Okay, yeah. Then that would match.
Which technically isn't in OpenGL, isn't your near plane -1 and your far plane +1?
Yes.
And that would also, and I guess in this case we'd be turning the near plane into 0.
Yeah, which that's just a choice of whether your near plane is normalized or not, but between -1 and 1 or 0 and 1. And I think 0 and 1 stays consistent with the rest of what we're doing here.
Okay, great. Yeah. So in that case, we should probably do Z positive forward, Y positive up, X positive right.
Hell yeah, I love that.
I found a great amusement in Aqua's comment.
Me too. You would not believe how hard it was to find a gyroscope image of that's Creative Commons. Like, just put it in your thing. I went with the plane. It was the easiest to read. Everything else was a nightmare.
Fair enough.
I'm to use Silk.net to control a plane.
I mean,
You should.
That's such a terrible idea. I don't
It's
think we're
genius.
safe enough.
I think we're great for embedded high redundancy systems. I think just one computer, my Raspberry Pi 2 running Silk.net is going to be the ideal control system for a plane, and there should be no backups.
Yeah, Silk.net compiles to Nano framework now.
Yeah,
we're chilling.
probably does.
That would be awesome.
I'm sure you could get it with at least some finagling.
Chicanery.
Yeah.
So yeah. One thing actually, speaking of the Euler plane, yaw pitch roll is intentionally, it's not in order of the axis as kind of much of a combo breaker as that seems on its face, right? Like, because if it was the x axis and then the y axis and then the z axis, then it would be pitch, yaw, pitch, roll, whatever. It would be different. Pitch would be
yaw,
first and
roll.
then something else. Yeah. I did it this way just to maintain the sensation of rotation, right? If you're rotating the yaw, it feels like you're rotating x. To me, that feels more intuitive. I'm flexible on that. Just yaw, pitch, roll in that order. It kind of rolls off the tongue. It's kind of the convention anyway.
I think that it might be better to stick with when you're rotating around that given axis, because I believe Unreal does it that way. It's very common because you're rotating that axis around, because technically when you roll, you also are rotating along, like, you'll see an X movement as well. Like, you're not necessarily gonna. Yeah, so
yeah,
there could
I'm
be
open to
some
that.
confusion.
There is
Do we
also
have
someone's probably going to want to construct a vector 3 of this and then pass that into functions. And generally, a lot of things they'll use the convention of rotating around x-axis, so it would be in the order of pitch, yaw, roll.
Great. I'm glad
that's
that's
how most of like C# standard library stuff and likely how Sylvan on maths. I believe that also does that. Is it has the order of pitch, yaw, roll and matching the relative axes.
So pitch, yaw, roll it is. I am swayed.
I'll make a note.
I will change that here, but may need to take note of that. Yeah, so as you might have gathered, a single axis could be assigned multiple axis groups. It's encouraged, but the ordering could become significant. So this gets pretty in the weeds of the definitions, right? So for example, let's say I have this definition where this group of axes, let's say it's my D-pad. Technically speaking, the D-pad could also act as face buttons in most scenarios. So I'm going to give it that. And then it's on the left side. So it's left-handed, of course. These are the axes. And it has a matching set on the other side, which is like the face buttons. That's the twin index. Let's just pretend that's 6 or whatever. So this is good, but whatever implementation follows isn't going to know like the primary purpose for this. Like, really, in reality, this is a D-pad. It's not really supposed to be face buttons. It can be face buttons. There's no reason why it can't, unless you're playing Street Fighter. But it really should be a D-pad. And so the way that you would define that is by, like, in your axis groups, you can, just basically duplicate the group and define them individually. And whichever one comes first for a given axis is going to be considered primary role. The primary purpose of these axes is to be the D-pad, and then after that, yeah, they could also be the 4 face buttons. But really, we care about being the D-pad more than anything. And so that's very much worth doing. Again, for things like the N64 as well, that sort of concept was here too, where like primarily these two, they want to be part of a larger C button, I'd say like group of face buttons. Like that's what they are directionally speaking. But they can also be part of the other one. And so if I were actually to do this, I would make sure that the C is defined prior to the A, B, and with the 2 C's. Does that make sense?
Mm-hmm.
Yeah.
And yeah, well, we reserve the right to expose extension methods to aim at the determining of these rankings of axes, because that could also get pretty in the weeds, because it's on an axis by axis basis, right? Like if this was hypothetically like axis 18 instead, or let's say over here, this was axis 18, that would change the logic. Whereas, I don't know, for axis 18, its primary group is the 4 face buttons group. It's not the one that comes before because it's not in that one. But yeah, and so here's an example of like the entire list for an I-axis device. Just missing a ton of buttons or groups potentially, but basically, yeah, you can have your little joystick with these two, with these 4. It has the twin index of 1, which, what do you know, is the next one, and that's the right analog stick, which has a twin index of 0. They love each other. They're twins, born of the same stuff, and so on. I think we've kind of like mashed axis groups with a sledgehammer. So safe to move on?
I do want to nitpick something about the GameCube controller. And I don't think this is actually probably going to end up being relevant to our implementation. But while I understand why you want that order, I do think having it in that order will confuse a lot of people, because if you're assuming a face button layout, you're going to be assuming that B is your cancel, A is your accept, at least for a the way that Nintendo does things, where that ordering is not going to match another Nintendo controller. Again, I don't even know if when we get this information from SDL will probably already be telling us that B is, because it'll probably be based on original face button layout. They may not tell us, so it may be irrelevant. But that's my nitpick there of doing it locationally well. Feels nice for consistency's sake. I think would end up being more confusing to a user, because a user doesn't really care about where it's located. A user is going to care about what button it is.
I disagree with that last point, but I also agree with the larger sentiment in that the culture of, I'll say, of using a GameCube controller differs dramatically from every other Nintendo controller. Yeah. Except for maybe the Nintendo 64, maybe.
The Nintendo 64 is another monster entirely. Yeah. Again, do they care a little bit where the buttons are? Yes, but I think you would confuse a lot more people if they were switching between like a regular, say, PlayStation controller to that. They will probably even still default to B being their cancellation button, which in this technically, the way this is laid out, it should be X that's your cancel, because that's going to be where your circle would be.
Yeah, in most cases.
Yeah.
Depending on, I guess, a weird where the game was made.
Nitpick.
Yeah,
because it would be
it's worthwhile. But there's also we can define several axis groups for this. I mean, my primary concern is mostly on accessibility's sake. If a game could be played one-handed, having this properly aligned would allow this to serve potentially multiple purposes as a directional pad as well, and button inputs and what have you. An analog stick could be a shift, but this could additionally be defined in any such way. For that reason, it'd be a bit. I don't know if that's the best way to go about it, but I do recognize that problem and was kind of considering that myself. I chose to ignore it, and I stuck my middle finger up at the execs of Nintendo saying, "Why do you curse me so?"
Yeah, it's a really weird controller design that is very alien. A lot of people really love those controllers. Yeah, like I won't, but it's so different compared to other, which is where I'm like, I understand what you're going for like a consistency of usage, but I think someone who picks up that controller is going to make certain assumptions based on that it's a GameCube controller.
Almost uniquely so.
I don't even know if us making this decision is going to be on us, because this is an implementation that I would expect the driver tells us that this is button 0, this is button 1, this is button 2, unless we are specifically checking, is this a GameCube controller, and therefore because it's a game controller, let's flip these buttons around. And I don't feel like we should be doing that sort of nitpick at runtime.
Yeah, I don't know. I don't have a strong, because I have not created bindings myself. I am in no place to suggest the way that we should interact with these backends in that respect.
I'm just literally thinking of like Windows calibration sensors. If you're gonna pull that up, it's not gonna tell you whether it's the B button, the A button, or where they're located. They're gonna be sensibly done somewhere in the driver level. It's probably not gonna be shown to us, so I don't think this matters too much, other than for illustration purposes, this might not match what we get out in the final version, which again, I don't know if that really matters. The idea is solid of we want to keep it kind of consistent locationally. But I don't know if that's necessarily going to be true, because I don't know if we're going to know that information.
Yeah.
Well, SDL, it actually does attempt to solve this problem as well. SDL provides two different ways of accessing controllers. You have treating every single controller as an Xbox gamepad, and you have accessing individual component controller, where each one is distinct. And so they do actually have some sort of mapping weird layouts of the game controller to an ABXY traditional layout of just for of mapping it to the diamond configuration. So I think it is actually possible to always provide the diamond configuration, and maybe it would be possible to also provide a different kind of layout where it's accept, cancel, and then two auxiliary buttons.
I do believe most controllers that run on Windows provide kind of a standard, like button 0 to button 1, button 2 is specific face buttons. Not positive about that, but I don't know if SDL necessarily has to do that mapping themselves, or are assuming it does.
The whole thing about SDL is that it's trying to be the same on all platforms, and so it does internally do all the mappings. So pretty much any type of controller you can plug in, they have this massive database that maps that controller to just a standard Xbox
GLF30 gamepad as well.
Again, I would then say that we should follow that mapping rather than giving our own mapping.
Well, SDL does both. It lets you access the raw controller buttons, and it also provides the mapping. There's two separate controller subsystems, if I recall correctly. So maybe we could provide two separate access groups and have two different types of access groups for the face buttons. You have your standard diamond layout of north, south, east, west, and then you also have something different, whether it be based on the actual text on the buttons, A, B, X, Y, which would map to the it's like A, I guess would, I don't know, map to X on a game on a PlayStation gamepad. But I think providing a differentiation between the physical positions of the face buttons and the actual physical text on the button. So in the case of the GameCube, you would want A to be select, B to be back, but that doesn't necessarily make sense when you've erased the text and the buttons and it's now just north, south, east, west. So I think it would make sense to have both the diamond orientation which is what we currently call four face buttons, and then we also have something else which is just generic, either select, go back, two auxiliary buttons, or just ABXY. So because it is slightly problematic.
Just a question because I'm not as familiar with SDLs, how it provides it raw. Does it provide it with knowledge of what that button is, or is it just saying button 0, button 1, button 2 are these values?
I think if I remember correctly, it does provide it based on knowledge of what the button is.
Okay, and that's just again, because this is something we could set up easily ahead of time. Yeah, it'll just have to be when we cross that bridge when we come to it.
I like the idea of having that as like an access group type in and of itself.
Yeah. The main concern that I would have with the main thing that I'm concerned about is PlayStation specifically, because in Japan, X is back, circle is select, but outside of Japan, it's X is select, circle is back. So I'm not entirely sure how we would handle that. I don't think trying to grab the user's locale is a good option, because
probably not.
I would say that honestly, we probably should, because it's the same with like if you're just taking the diamond configuration. I think usually they place A at the bottom and B where circle is, but that's not always the case, because Switch controllers are reversed. A's on the left and B's at the bottom. You could have something that is a simple option that is switch those two value wise, that we could have someone pass into us.
Maybe, for just
there could be an access group that is a select and cancel, like literally just those two.
That would work, because it's usually what this is what people want, is select and cancel. But again, how do you know which select and cancel you want, whether you're talking about the Japanese locale / Nintendo style, or are we talking the more standardized outside? Because you probably will still want user input there of which one you set up.
So I think in the term, I think in the case of Nintendo, we can just treat it as A is select, B is back. So wherever the buttons lie, that's fine. People will figure it out. But in the case of Sony and how X and O are kind of vague when it comes to select and cancel, maybe it would be best to provide some sort of way of telling Silk, okay, I would like this region of standard, because at least all I know about controllers, the only ever differences that happened were region to region. Like how in the Famicom, the Famicom, it was button 1 and button 2, but in America it was A and B. So I think perhaps it would just be region wise. So it would be, if we do new region which handles it differently, we can just add a new region to the enum, and then it'll be backwards compatible ABI wise and source wise. So I think what we should have is we should have the input accept a region value, and the whatever game developer can figure out, like, okay, I'm making my Japanese Xbox build. That means I should be using the Xbox. I should have that in, or
honestly,
or like an option
probably
settings
could
for whatever you want.
Yeah, like you could use simple language codes for, is this a .jp, is this US?
It's not
You
a
don't
perfect
have to be,
mapping. Like
but we could get it
personally,
pretty good.
yeah, like personally with my consoles, all my consoles are set to English, but I use the Japanese mapping for all my PlayStation consoles, because I have all imported consoles. So it's not like a perfect mapping to just use the language, but when it comes to publishing to a console, we
Oh
make
yeah,
special
no.
builds for platform. And when it comes to PCs, you can probably use the language as like a fairly fine mapping, and then let games could let you like choose an options. So
Yeah.
I think a select cancel and then two option buttons. Maybe they should be called action buttons. But I think having that and then you pass into Silk the region. I think that would be a pretty
Yeah.
good solution, which would let people, because like for your gameplay you might want four face buttons, but for your menuing you might want select cancel. So I think having those be distinct is actually like very nice for game developers.
Mm-hmm.
I'm not entirely sure what the best way to do it from an API perspective, but from the higher level API, but from the lower level API, I feel like the Axis device, if it were to support this inherently, should have select cancel, and then in that implementation of that device would be doing like locale checking and such if they need to.
Yep.
Well,
for
the
their
problem is
creating it.
is you don't know, like there's no way to necessarily know what your locale is unless it's like there's a lot of questions of whether you'd know that information,
Mhm.
and technically locale is not entirely
Yeah, it's
the
not trustworthy.
yeah,
Yeah,
so I think
'cause
giving it to just the developer to say the developer can choose which locale they want to pass to us, then they can make that decision. Because then
yeah,
they can
'cause
choose
like
to ignore it or not.
yeah, because in my case, my locale is English, but my button layout is Japanese for all my consoles. So when I'm using a PlayStation controller, I'm most used to using circle to select.
Mm.
So I
Okay.
think letting the developers pass it in and then expose that option to end users, I think that's probably the best option. I don't think Selknet itself should be trying to touch the system locale to determine it automatically. I feel like that's just a bit overreaching.
Probably.
So I think it's best to just have the default be, um, I guess the default should be the default locale, so no special handling, which in
So
the case
why?
of the PlayStation controllers would be X for select, and then have a separate enum option for Japanese, and then if we ever find any more exceptions, we can add that to the enum.
Yeah. So let's move on, and we can shelve this for a further time. Wait, hold on. We have someone in on the stream has something to say. I believe he's raising his mouse aggressively.
Oh, no, I'm just trying to keep myself awake. That's not an insult to
no
the
feeling.
subject matter. That's
No,
that's
I know. It's very
UK time.
Yeah. So I have to go soon anyway, so I kind of want to fly through some of the rest of this.
I mean,
Yeah.
it sounds like it sounded like from earlier with the output type of thing, so we might want to regroup on this anyway.
Yeah.
We'll cover what we can,
stuff.
and have some words that we can hopefully take into a second go, and maybe add another call or take it offline, whatever.
Okay. So dead zones, naming to be determined. We should shop that probably in chat at some point. For like some of this stuff, but basically there's a struct for a dead zone, which takes a zone in, which is the X is the minimum dead zone, the minimum value of the dead zone, and the Y is the maximum value of the dead zone. And so in most cases, it'll probably X will be 0. And so there are multiple constructors to like support like the more intuitive case. And then there's a logical Boolean here for how those values are mapped. And there's an additional noise value, like expected noise for things that for an implementation that adapts to like noisy inputs, which is often the reason why we have dead zones in the first place. Yeah, I think that's pretty straightforward. And then just in terms of implementing that, there's an iDeadZone handler name to be determined. And then that just has a few methods that you need to define, namely, get the value given the dead zone. Bool, is it in the dead zone? Is this group in its larger dead zone? Say if it's like a joystick, or is this group in its dead zone with an individual dead zone per axis versus one dead zone for all of them? That makes sense?
Yeah.
Yep.
Any feedback on that in particular before we move on?
No, I don't think so. We do need to bike share the names. My primary objection is to iDeadZone handler is what we use for the AXA-like interfaces that receive device events. But that's the main thing.
Yeah. So
Resolver
my thought was
might
that
be
this
another
would kind of end up being something like that, but we get more in depth about that later on.
Yeah. Sorry, what did you say, Kiri?
iDeadZone resolver is another name. I understand it's not quite a handler in the fact that we call handles for like our actual pointers, and that's I think where calling handler gets confusing because it's so close to that.
See, I like that one. All right, we'll work it out. I like iDeadZone resolver. We'll figure out where this fits into the larger API or clarify that, because I've noticed for some time I don't really have the injection point for this anywhere, really. And then last but not least is the output side, which largely mirrors the input side, save for a couple of considerations, some of which might not be fully fleshed out here yet. We have some pending feedback from Perksy. But seeing as it was 2:05 p.m., here we are.
Yeah.
So we have basically on the basic level, most people would end up using this sort of thing for like haptics and LED control on your controllers or keyboards or whatever. And so similar to the axes, there's an output description and an output group. Additionally, in the I-axis device, these are present. There's a function called set output where you just set that output as a value between 0 and 1. And then there's a more generic version of it, which is a bit in the works, but it's basically a way of treating arbitrary data. Like let's say, for example, the controller has like a small LCD display. Let's say it's a Dreamcast memory card, or it's it has a speaker
Logitech
in it.
G15.
These sorts of things, or it's a Logitech G15. We kind of want a way to do it. It's not the happy path for sure, but it should be something that exists, so then higher level utilities can utilize it, or even if they're going around it, we want it there.
Yeah, so for context,
Yeah,
this mainly came from implementing like iPointer on top of these devices. Like, there's no way that we can set the cursor mode, for instance. So that's and similar motivating examples. Sorry, Betty.
Yeah, there is also an OpenXR extension for that some controllers equivalent, which let you send raw PCM data for haptics. So while this is meant for creating like precisely controlled haptics, like a triangle wave is going to feel different than a sawtooth wave. That's different than a square wave. However, you can also just use it to play music, which is fun. But I think that some controllers and OpenXR itself does actually support this, at least through an extension. So I think, yes, that output does make a lot of sense for that as well.
Well, that's awesome. I was thinking about the link of haptics and audio, but I kind of figured it wasn't really a thing that was formally supported. That's awesome that it is.
Oh yeah, it's very fun.
But yeah, then there's output traits and output descriptions. so output description being the struct that defines an output that are indexed just like axes in the same way. They have their traits. An associated axis, for example, if this output is connected to like the shoulder button of a PS5 controller and it's like the give thing, the force feedback, or if it's like an LED for a specific button when you press it, you could put the axis index there. Is available, the name and all of that, and the traits are pretty minimal. Again, this was just invented today, but we have like LED, haptic, force feedback, and vibration motor for more specific haptics. Whether or not it's like a device control for like device firmware, or if it's a virtual device, it could apply to like things of that nature if we want to go crazy. And then raw data only, left side, right side, all that's all the same. And then for the output groups, this is pretty much the exact same format as the axis groups, and the output group types are similar in that we have LED, similarly like RGBA convention like we did with vectors and XYZW. And then haptics basically define groups of haptics and vibrations, like sets of them. There's a dynamic thing, and left and right. And that's everything.
Yeah. I mean, it's cool. I think we need, as you said, there were outstanding comments on the outputs, and I encourage people to look at the pull request that is currently opened for this proposal. I don't have the number off the top. I should probably be responsible and say the number of it. It is pull request 2415. And yes, so I like it. It's because we do need a more generalized thing for when we come to build things like the input actions model. As you said, we need to look more into the outputs side of things and flesh over some other things in the proposal. But I've enjoyed the discussion today. It was lots of useful comments, and I'm happy with it. I think we will be coming back next time to finish off the review for this, I guess, and to also incorporate the other comments that we've raised today. But yes, I liked it. What's everyone else's thoughts?
I think generally it's a good, yeah.
I think it covers a lot of use cases that are hard to tackle in a lot of other ways. The groups are especially like super flexible, and that's really neat.
Awesome. Well, I won't approve this proposal today. I will put the comments that we've got on there. Because I don't think we have enough information for approval, and which is fine. We can it's not going to be 8 months until we have another working group meeting, so we will put one in. I don't know. It could even be next weekend. It's or just whenever it's ready. Kieran, we can talk about what we're talking about in the maintainers channel at the next working group meeting as well.
Makes sense.
I figured
we ran a little late today.
Yes.
I tend to have that effect on this group. Sorry.
But it's good. This was a good thing to get across, and there was a lot of information that needed to get through. Like, we've gone through 4 different proposals today, and most of them were beefy. So
yes,
it just was.
Yeah, no, it's been productive.
Awesome.
Don't think it hasn't been. It's this is ultimately something we have to get right when we're making such a low level generalized API that we can potentially end up being stuck with if we don't get the right abstraction. So it's all valuable conversations to have.
All right. Well, I gotta fly, and I'm sure all of y'all are wanting to live your life. So thanks for listening, and it was awesome that we got through so much stuff today and all these proposals.
Thanks for spending the time to actually make that proposal, because that was not a small endeavor.
Yeah.
Yeah.
I wish. Yeah, thanks for recognizing that. Yeah, we'll push this over the finish line soon.
Yeah. I will
See ya,
coordinate
fam.
with everyone for the next time, and yeah. Thank you everyone for watching the stream, and yeah, goodbye.